Good morning and welcome to the November meeting of the University of Wisconsin Board of Regents. In recognition of Veterans Day on Monday, we're honored today to have with us the University of Wisconsin Naval ROTC Color Guard, commanded by Color Sergeant Midshipman 2nd Class Jacob Friend. At this time, I would ask all of us to please rise for the entrance and the presentation of the colors.
Order. Color. Ready, sweep. Ready, cut. Post.
Thank you. You may now be seated. I would also like to invite any and all veterans and active military personnel in the room to please stand and be recognized. We thank all of those who wear, have worn, or will wear the uniform in service of our country. We have deep respect and gratitude for those who serve both on and off the battlefield, those who steadfastly stand on guard to ensure our freedom, our security, and our way of life. Thank you. President Cross, I believe you would also like to say a few words this morning.
Thank you, Regent President Peterson. Good morning, everyone. I would also like to individually recognize and thank members of the Color Guard for their service. Midshipman Second Class Jacob Friend, Midshipman Third Class David Moroff, Midshipman Third Class Michael McCabe, Midshipman Third Class David Bondi, and Midshipman Third Class Donovan Lauda. Let's give them a round of applause.
Right face. Forward arm. Forward march.
So I would like to say that as these Navy folks leave, as an old Army guy, these Navy guys didn't do a bad job, did they? Thank you, gentlemen. Regent Peterson.
Thank you. Turning to today's business, Madam Clerk, please call the roll.
Regent Peterson.
Here.
Regent Greeby. Here. Regent Atwell.
Here.
Regent Bechtel.
Here.
Regent Delgado.
Here.
Regent Hall.
Here.
Regent Jones.
Here.
Regent Klein. Regent Levzo.
Here.
Regent Manydeeds.
Here.
Regent Mueller.
Here.
Regent Peterson. Regent Plant.
Here.
Regent Stanford Taylor.
Here.
Regent Tiedemann.
Here.
Regent Walsh.
Here.
Regent Whitburn.
Here.
Regent Woodmansee.
Here.
We have a quorum.
Thank you. Before we consider items on today's agenda, are there board members who wish to declare any conflicts of interest with today's agenda? Okay, hearing none, we'll move forward. The records of the October 11-12, 2019 Board of Regents meetings have been provided. May I have a motion to approve these records?
So moved.
May I have a second? Thank you, Regent Hall. All in favor, say aye. Aye. Opposed, same sign. Motion carries. To lead off my report this morning, I'm pleased to report that earlier this week, the legislature voted to approve appointments of Regents Edmund Manydeeds, Karen Walsh, and Olivia Woodmansee to serve on this board. Let's give them all a hearty. Welcome. Turning to our All in Wisconsin campaign, we've now hosted events at 6 campuses, most recently at UW-Oshkosh and UW-Stevens Point. The response from those attending in the local media and our partners has been very, very strong. It's clear that people feel a strong connection to the UW campus in their area, and they're eager to build on our current relationships. Our next stop on the tour is November 20th, when we're doing a doubleheader with both UW-Stout and UW-Eau Claire. Then we'll close out the year with an event at UW-Whitewater when they host our board meeting in early December. To find out more, check out our All in Wisconsin hashtag on Twitter or the stories on our wisconsin.edu website. Now for some news on updates of current searches. UW-Stout is moving one step closer to naming a new chancellor. Late last week, the Search and Screen Committee, chaired by Regent Jason Plant and Associate Professor Julie Bates-Maves, advanced 4 candidates as finalists. In the next few weeks, each candidate will participate in separate public forums, offering opportunities for students, faculty, staff, and community members to interact with them directly. President Cross and the Special Regent Committee will then interview finalists on November 19th before recommending one candidate to the full board for approval. Turning to the chancellor search at UW Green Bay, the Search and Screen Committee led by Regent Bob Atwell and Professor Michael Duraney is currently identifying candidates. It's expected that semifinalists will be named sometime in early January. Next, following President Cross' recent announcement that he intends to retire, last Friday, I appointed a 9-member Search and Screen Committee to help identify the next president. Regent Vice President Michael Greeby has agreed to serve as chair of this committee, which includes current regents Mike Jones, Ed Manydeeds, Tori Tiedemann, and myself. The committee also includes UW-Madison Chancellor Rebecca Blank, UW-Superior Chancellor Renee Wachter, Regent Emerita Regina Milner, and UW-La Crosse Provost Betsy Morgan. The committee is expected to convene in December to launch this national search. I'd like to take the opportunity to thank all of our regents and others that are participating in these searches. It's one of the most significant things that we do. I also know it's a significant time investment, but this is incredibly important work for the future of our students, our institutions, and the state. And your attention is much appreciated. Finally, I will have many accolades to say about the opportunity to work with my friend and partner, President Cross, but since he's going to stick around for a while, I'll save those for a later date. That concludes my report for today. President Cross. Actually, I'm keeping the mic.
Yeah, that's right.
Before I turn the mic over to Chair Jan Mueller, are there any members of the board that would like to recuse themselves from any items from the Business and Finance Committee today?
President Peterson, I'm going to recuse myself on one of the contracts between UW-Milwaukee and APT Manufacturing Solutions.
Thank you, Regent Bechtel. Just please denote that. And at this time, I'll turn it over to Regent Chair Jan Mueller to present a report of the actions taken this morning by the Business and Finance Committee.
Thank you, Mr. President. We did in fact meet earlier this morning to approve our October 2019 minutes and consider a contract from UW-Milwaukee and 3 contracts from UW-Madison. UW-Milwaukee's contract involves APT Manufacturing Solutions. It's a contract with them to further the work of the university's new Connected Systems Institute. It's expected that this test bed that's going to be constructed will help optimize performance and efficiency of the tests that will be done there. Total payments are not expected to exceed $1.3 million to APT Manufacturing. We next heard from UW-Madison proposing a master research agreement with American Family Insurance designed to focus on research and develop web-based solutions to data analysis as part of their new operation there in the data sciences area. The university will receive approximately $10 million for deliverables related to this project. Next, UW-Madison School of Medicine and Public Health seeks to contract with Allergen Sales over the next 3 years under a master services agreement. The contract ending in 2022 is expected to pay in excess of $1 million. The research here is on age-related macular degeneration treatment. And the final UW-Madison contract is again with the School of Medicine and Public Health, this time their Department of Radiology, to develop software tools with Change Healthcare Technologies to assist radiologists in using medical images to diagnose disease. This agreement was originally executed in 2016, but there's been a successor company, Change Healthcare Technologies, and now is expected to pay over $1 million prior to the May 2021 end date of this particular contract. So, Mr. President, in conclusion, on behalf of the members of the Business and Finance Committee, I would now move for approval of 4 contracts, agenda items B, C, D, and E.
Thank you, Chair Mueller. Do I have a second?
Second.
Any discussion? All those in favor say aye.
Aye.
Aye. Opposed, same sign. Motion carries. Moving on to item 5. With Veterans Day just around the corner, we're pleased to have a presentation of the University of Wisconsin Missing in Action Recovery and Identification Project. The main goal of this program is to research, recover, and biologically identify the remains of missing in action service members, of which there are an estimated 82,000, including 1,500 from Wisconsin. At this time, I'm honored to turn the floor over to our colleague, Regent and U.S. Marine, Tori Tiedemann. Tori.
Good morning. To develop human resources, to discover and disseminate knowledge, to extend knowledge and its application beyond the boundaries of its campuses, and to serve and stimulate society by developing in students heightened intellectual, cultural, and humane sensitivities, scientific, professional, and technological expertise, and a sense of purpose. Inherent in this broad mission are methods of instruction, research, extended training, and public service designed to educate people and improve the human condition. Basic to every purpose of the system is the search for truth. These are qualities and aims that are also integral to the University of Wisconsin Missing in Action Recovery and Identification Project. One example of the Wisconsin idea in action and a true demonstration of the furthering of the mission of the University of Wisconsin system. President Cross, Regent President Peterson, fellow regents, chancellors and provosts, distinguished guests, ladies and gentlemen, it is my pleasure to introduce the following members of the team. Mr. Charles Konsitsky, Associate Director of the UW Biotechnology Center here on campus, a UW lacrosse alumnus, and founder and team lead of the UW-MIA Recovery and Identification Project. Ms. Samantha Zinnin, a UW-Madison alumna and the team's historical research lead. Ms. Alicia Lawson, a UW-Madison junior majoring in history, anthropology, and pursuing a certificate in archaeology and the team's student lead. Mr. Chris Zajac, U.S. Army captain and armor officer and new father, now attending UW-Madison School of Business on active duty orders to earn his MBA, which he will be finishing this spring, and the team's operations manager. Dr. Greg Jameson, professor of anthropology at UW-Milwaukee at Waukesha, also a UW lacrosse alumnus, who received his PhD in anthropology at UW-Madison and is the team's field principal investigator and archaeological lead. And Ms. Emily Eisman, a graduate student at UW-Milwaukee pursuing her master's in anthropology. Also seated in the audience is Dr. Ryan Wubin and Professor Nam Kim of UW-Madison. I'd also like to acknowledge Dr. Sarah Clayton of UW-Madison, who got me involved in the project, referred me to Mr. Charles Konsitsky, and Dr. Brett Hoffman of UW-Oshkosh, who is Dr. Jameson's assistant in the field this summer, as well as our other volunteers. You will now hear from them. Team, the floor is yours.
Good morning, and thank you for allowing us to speak today. So, as Tori stated, we are the UW-MIA Recovery and Identification Project. As you can see, as the statement states above, I will always place the mission first. I will never accept defeat. I will never quit, and I will never leave a fallen comrade. So the project was started in 2015 with a unique case that we dealt with PFC Lawrence Gordon, which I'll speak about a little bit later. Independently, we were the first academic institution to partner with DoD in such a case in 2016. DPAA is the Defense POW MIA Accounting Agency, and they were struggling with performing recoveries. In the congressional, they made some organization changes there, and one of the goals was to advance the recoveries, and that's when we got involved in discussions with them regarding a strategic partnership. And then with that, we've had 3 successful missions from that point. As many of you may not be aware, we are all volunteers. We all have full-time jobs. Students have full credits. So we are all taking time out of our life to move this project forward. And to just give you the impact, as the president stated, over 80,000 U.S. service members have not returned. Of that, 1,500 of them are from Wisconsin. And this is just a visual impact of that. So this is a statewide issue. It's not a Madison issue. It's not a Milwaukee issue. It's not an Oshkosh issue. It is a statewide issue. One of the reasons why we determined it a UW project and not a UW-Madison project. So of the heroes that we brought back home, First Lieutenant Frank Fazekas, PFC Lawrence Gordon, Second Lieutenant Walter Stone. To give you just a little bit of background regarding PFC Lawrence Gordon, he was a Canadian who was working in Montana when the war broke out. He joined the U.S. military, was killed in action in France, was misidentified as a German soldier, so he was buried in a German cemetery in France as a Canadian. The civilian researcher who came into our center, at the Biotechnology Center, had asked us, can we perform DNA analysis? And I had asked him, we can, what's the project? And he explained the story, and I was intrigued, and I got a little bit involved. And what I've learned with this interaction with the civilian researcher is how a DoD can be difficult to work with sometimes. So we proceeded with this project. We worked with the Canadians, we worked with the French, and we worked with the Germans. The only country that would not work with this individual was the Department of Defense. So we assisted with this recovery mission. We are the only university within the nation that performed biological analysis that has been confirmed by DoD. So we showed DoD that we can power up with them. As you can see, we recovered PFC Lawrence Gordon. The remains were flown into O'Hare. We had a police escort from O'Hare to UW-Madison. We performed the forensic anthropology here, the analysis, and he was returned home to be buried in his family plot. First Lieutenant Frank Fazekas was our first case that we aggressively took on with the Department of Defense in 2016. We pulled together the discretionary funds we had within the Biotechnology Center, and we informed DoD either partner up or move aside. They partnered up, and it was a success. And the director of that strategic partnership called me the Friday that I returned, and he said this was the best day of my job. So you could see the impact of academic was plain, and they could see it as well. We were the first academic institution to perform a recovery in 2016. The following years, we recovered Second Lieutenant Walter B. Stone. He was just buried here May 11th. He was Walter, or as stated by the family, Buster, was a fighter pilot with the 350th Fighter Squadron. He was guarding bombers on the way to a mission and disappeared from his squad. We went to the site. In 20 days, we performed what most people would probably say a miracle with the students, staff, and faculty working this site. In the middle of a national forest in France, the French were very welcoming. They gave us full access to the site. The administrators of that site also were there on a daily basis, checking in, what do we need? Oops, sorry. Oh, we have I'm missing some slides. So as you can see, the impact of Wisconsin, nearly every community in Wisconsin has been touched by the loss of a service member. This is an image of PFC Frank Fazekas' crash site. And then this is just a global showing of the impacts of Wisconsinites throughout the world. So why UW? One, education and research. We are dealing with technologies that are at the cutting edge. DoD is starting to witness this. Leadership development. If you look at our past students, some are police officers in Milwaukee. One is an officer within the Marines. Actually, two are now officers within the Marines. One is an officer at Truax right now, ready to start flying hopefully the new jets there. Communication, teaching students, staff, as well as faculty, how to better your communication in a high-stressed environment, because it is stressful. To give you a case, last year we moved 304 cubic meters of soil within 20 days, and that's sifted as well. Teamwork, we have to work as a team. Giving these individuals that experience, face value, gives them a better understanding of how to proceed in the future. And continued service. We as the UW system owe it to our state to provide this service and continue moving forward. Thank you.
I got involved with this project a few years ago when I was a student at the University of Wisconsin-Madison. There was a History 600 class on recovering America's World War II MIAs. This was a pilot program that the university ran with the DoD to figure out if upper-level history students could help work and help move these cases forward to be solved. With over 82,000 MIAs across the United States, having upper-level history students help do digging and work and provide research is an invaluable resource and provides a manpower problem and a manpower shortage when you're considering looking at these cases. I continued that work after joining the team and wrote my senior honors thesis on Wisconsin MIAs and the relationship between having an MIA and how it affected that town's development in their community. And I can personally tell you through my research on towns like Beaver Dam, Wisconsin, that the MIAs and their experiences in World War II, it's an ongoing trauma that has shaped their community. These losses for these families have not stopped. The pain didn't end in 1945 when we declared victory. The loss is an ambiguous loss that continues through this day. And the work we do in providing closure to those families and those communities provides our history back, and it is our duty. Working with students now on campus and across the UW system allows them to work on Wisconsin cases and providing incredible research, helping them gain new skills and perspectives that could not be gained inside a classroom, while helping bring closure and move MIA cases forward. The students we get to work with are incredible, and the research they would do would knock your socks off. They're discovering cases when they start with a name, a serial number, a date, and a unit they were involved in. And from that, they figure out what happened, where they were, and the incident, as well as everything about their life. Because when we write up a report, it's not just the worst 5 minutes that resulted in this soldier becoming killed in action and never being returned to their family, but their life as a whole that was cut short when they went and served our country. Some of whom they discover went to UW-Madison or other schools and were students just like we were. The historical research that our students are involved with and the way they dedicate themselves to our urgent mission of bringing home our Wisconsin MIAs while gaining experience, skills, and perspectives that can't come from a textbook and is the Wisconsin idea in action. Their research can not only help directly change and outcomes and cases, but impact families and communities across the state and the nation. Thank you.
Good morning. My name is Alicia Lawson. I'm a junior here at UW-Madison, majoring in anthropology and history with archaeology, classical studies, and leadership certificates. I have held an interest in World War II since I was a kid. I started volunteering with the UW Missing in Action Recovery and Identification Project this fall as a student historical researcher. I was drawn to the UW MIA RIP because of my grandfather. He was a flight engineer on a B-29 in the South Pacific during World War II. His older brother fought through France to liberate Paris. Both were lucky to make it home. However, many of their friends on their street did not. This project allows closure for families of the missing after a lifetime of wondering. Since I began this September, my work has focused on researching and locating Wisconsin MIAs who were crews aboard downed planes in the European theater. It is a long, rarely straightforward, but rewarding process. It is my job to learn everything I can about all of the crew members, the plane, and the mission. Not only do I pull from eyewitness accounts from other planes' crews on the same mission and after action and missing aircrew reports, but also from European local stories, German reports, and the familial stories of other surviving crew members. My first case involved a down B-17 in France, which had an MIA Wisconsinite on board. I began with solely the plane's type and serial number, as well as the soldier's name, rank, bombardment group, mission target, and crash date. This is not a lot of information when trying to put together the rich narrative surrounding this crew and events. However, it is always a collaborative effort with unexpected surprises. One such surprise was how the town in which the B-17 crashed has memorialized the fallen American soldiers through a monument and the inclusion of the crashing within their local history. Another research strategy I used was reaching out to the soldiers' bombardment group through social media. It is a very active bunch of veterans and family members and has connected me to the family of the crew members who survived the crash and were taken as prisoners of war. They have provided me with images of the plane and crew, as well as the survivors' firsthand accounts of the crash that were passed down through the generations since World War II. One challenge I have faced with these interactions is making sure I do not provide these people with false hope. As a policy, we never disclose the names of the MIAs during the research process, so the families do not raise their hopes only to have them dashed in the end. Finally, the military documents from both Allied and Axis forces have helped in the reconstruction of the B-17 crash. The American documents I reference include enlistment records, service records, and missing aircrew reports. These reports are usually completed soon after the mission and include the general crash locations, survivors' accounts, and much more. What is not usually considered are the German files of the downed planes, written by the ones who are exploring and documenting the crash, as well as capturing the surviving soldiers. In this specific case, the only picture I have of the B-17 post-crash came from a German file. This research I perform with UW-MIA RIP helps me not only expand and hone the skills I have learned in history classes, but also develop new ones. I am beginning to explore archival research with Samantha's help, which is a rare opportunity for students on any campus. This project is so important to the people in Wisconsin and beyond the state. It is essential to preserve and respect our nation's history. Thank you.
Good morning, everyone. My name is, can everyone hear me okay?
Use the microphone.
Okay, well then I'll use it. So good morning, everyone. Thank you for the opportunity to speak. My name is Chris Zajac. I am, as Tori said, a second-year MBA in the Wisconsin School of Business here at Madison. I am a captain in the Army, and I have had the privilege of serving as the operations manager for the MIA team over the past few months. I want to talk to you a little bit about how data analytics, database building, and those types of activities are helping shape the way we look for and interact with our MIAs. And you might be thinking to yourself, based on everything you've heard up to this point, that this business that we're in is honoring and telling the stories of service members. So how does data analytics fit into that picture? Well, it does it primarily in two different ways. The first way that it does it is it allows everyone to interact with the data that we're seeing in a meaningful way. So to follow up on one of Chuck's slides, if you take a look, this is Wisconsin in 1941. And these were the MIAs that were suffered, broken down by service component, which is denoted in color, which you can read. And if we follow the timeline out through 1972, when Wisconsin suffered its last MIA, you can see that the results are fairly staggering as we move along. There are very few, if none at all, communities within the state that have not bared the burden of significant loss of missing a loved one in service to their country. So it's over 1,500 different points on that map that are spread out in density fashion. But the new thing that this allows us to do beyond telling those stories is it actually allows us to research better while allowing people to visualize the information that we're seeing much better. So a lot of folks, when they hear database, think of kind of the standard Excel spreadsheet that you have to sift through and find what you need. We can take that a step farther. If you take a look at the map, if we want to hone in on Milwaukee, we can just click on it, and then we can see the aggregate numbers, but we can also move in and we can start to pick through every single name within the city of Milwaukee, broken down by their war, by their service component, and where they came from, the unit that they served in, and when they went missing. We can also do other things with it, and this is where we can kind of start to get into the second part of how data analytics is helping us do what we need to do. If we take a look at a global map of Wisconsin's MIA, this is the last known location of every single missing service member in the state of Wisconsin, scattered across the globe. If nothing else, this helps highlight the severity of the problem. But more than that, it helps us find places where we have larger densities of MIAs that we can start to look for. So if we just queue up a search for Belgium, we can move in and we can start to look at how many personnel are missing from that particular country in much the same way we did before. And you can start to break it down there. This is particularly important for us because we do have existing relationships in countries where we've conducted recoveries before. So being able to know exactly where we're going to sleep, how we're going to eat, who the contractors are that need to do critical service for us is very, very beneficial when we're talking about reducing cost on an all-volunteer team. But let's take this a step further. If you listened carefully to Sam and Alicia talk, you heard that a lot goes into researching these cases. What they didn't tell you is that in the Google age, most of the documentation they need to complete this story is not just readily available at the click of a button. They need to go out and search. And a lot of the documentation that they referenced is scattered across the country in different file sources that they need to travel to, get hard copies of the information available, and then sift through individually. So how do we take a volunteer force that has to travel all over the place and then pull data and hone that in to be able to manage our resources effectively so that we can get the most recoveries possible? Well, efficiencies like that can come beyond just global maps. And what we can do is we can start to look at timelines of conflicts, and we can see Wisconsin's history play out day by day and look for patterns where more Wisconsinites went missing. You can see that as we go through every day from 1941 to 1972, there are distinctive spikes and also distinctive service component spikes. The service component spikes are extremely important because the determination of service component is our first step in assessing a probability of a recovery. It's unfortunate to say, but there are some recoveries that are easier than others. Single-engine plane crashes come at the top of the list. After that, you're followed by more types of plane crashes, infantry on the ground, and then unfortunately, in some cases, naval losses at sea. Recoveries are very difficult with current technology available. Being able to see spikes in densities helps us to be able to hone our efforts in to figure out what's probable and what's not so we can bring more Wisconsinites home faster. But if a giant aggregate timeline from 1941 to 1972 doesn't quite work in honing it in, we can take it one step further. And let's take World War II, for example. So what we've done with the data available is we've laid out World War II month by month, year by year, and we've looked at every single day, and you can see a distinctive spike. But also part of the analysis that's being done here is density analysis. So what you're seeing is that shades that are darker on this map represent areas where there are more MIAs in fewer numbers of locations. By being able to hone in the day and the location over more MIAs, we're actually able to target specific sites where we could find greater numbers of MIAs. But it also provides interesting insight to us as well. So if we take a look at October 22nd, 1944, this is the worst day in Wisconsin's history for MIAs. With this software, at a click of a button, we can take a look and we can see that if you follow it, over 69 missing in action Wisconsinites were recorded that day, and most of them came from the Arasan Maru, which is a Japanese hell ship that was sunk as a prisoner of war ship. It's a particularly horrific story where lots of folks lost their lives and have never come home. But it allows us to see and break down those types of things in order to make our chances of bringing Wisconsinites home even better. So all of this leads up to one final conclusion, which is that no matter how much work we do right now, this is still a huge problem for our country. And what you're looking at is the number of missing by state. With this type of research and with this type of work, we can partner with other institutions and share best practices that allow us to help solve this problem and put the University of Wisconsin system at the forefront of tackling this challenge for the country. Thank you.
Good morning. Thank you all for being here today and allowing us the opportunity to talk about our project and its significance. I am an instructor in anthropology at UW-Milwaukee at Waukesha, and I've also been an archaeologist. I just finished my 20th year of archaeological field experience. First as an undergraduate student at UW-La Crosse, then as a graduate student here at UW-Madison. I worked in the private sector as a professional and more recently as an instructor. And I can say without any hesitation that this is the most valuable and rewarding thing I have ever done professionally. I'm extremely grateful for the opportunity to participate and to talk to all of you about this experience briefly today. And what I would like to do is talk for just a few minutes about two things. What we actually do when we are in the field doing our recovery missions, and then what we think are some of the benefits for our student volunteers. In some ways, what we do on our recovery missions is very, very similar to what we do in other archaeological projects. We use fairly standard archaeological field methods. We go out and we try to locate a site, we survey it. When we find a place to dig, we excavate it. We do that by hand, we do it by machine. Sometimes it can be pretty difficult. We use some pretty heavy equipment to do our excavations sometimes, which is not terribly uncommon, but can be very, very challenging for everybody involved. After we excavate soils, we'll sift them, screen them, and then we do analysis of the materials that we recover. These are all standard archaeological research and field procedures. We also do documentation of the things we find and the ways we do them in fairly standard ways. We take extensive notes because once we're done digging, what we dig is gone. So it's really, really important to document what we're doing and how we're doing it. We create maps, we take lots and lots of photographs, and then we classify and count what we find. And we are doing that while we are in the field, as you can see in the picture here towards the bottom of the screen. But in other ways, what we do is very, very unique and different than other archaeological projects. We have serious time constraints, as Chuck mentioned earlier. In most cases, at least in my involvement so far, we have less than 3 weeks to complete our recovery missions. And that is a time frame that is very, very challenging to meet. And because of that, we rely heavily on machines to help us do our excavations. In fact, in every one of these that we've done, we've brought in a backhoe or some other kind of machine and had that help us with our excavation a lot. And that can be very, very challenging. If we had our way, we would prefer to be able to spend more time and not have a backhoe come and dig out the whole site. But this is the reality of what we do. And so it's very, very important and very necessary for us to work with local people to help us be able to conduct the recovery operations. And in the process of doing that, we excavate a tremendous amount of soil. And we have to process all of that very, very quickly, which you can see here on the screen. And these are different in many ways than what we would expect in standard archaeological research projects. Another thing that's quite different is that we have very little opportunity for post-field work analysis. When we are done with the field operations, the excavations, everything that we find is sent to the DOD. And so almost everything that we do and want to do has to be done while we're doing it, which can be very, very demanding and challenging, especially when we have such a limited amount of time. It is remarkable and a testament to our student volunteers that we are able to successfully do this, because it is extremely difficult to be able to do, yet, as Chuck said earlier, we've been very successful thus far. I think that this is a very, very good example of what many people would refer to as applied archaeology. This is not strictly academic. We try to incorporate academic elements of research into our project, but what this really is applied archaeology. We are using archaeological research methods and data to try to solve real world problems, specifically to try to locate, identify, and bring home remains of our lost heroes. And in doing this, we're also able to provide unique learning opportunities for our students that come from a wide variety of different personal and academic backgrounds. Our project provides learning experiences for students in a variety of fields. You've already heard about some of the students who are coming from history backgrounds. Sam in particular has done an amazing job doing genealogical research. We have volunteers who come because they're interested specifically in archaeology, forensic anthropology, biological anthropology. A wide variety of disciplines are represented. And this is good. It's one of the strengths of our project. But the recovery operations themselves, of which I am directly involved, provide them with hands-on experiences in archaeological research methods, many of whom plan to use these later on in their careers. The project also teaches our students problem-solving and leadership skills, some of which have already been alluded to, as well as the value of volunteer service, which is extremely important. Through this project, we're helping to train the next generation of leaders, and they will utilize the skills gained on this project to help exemplify the Wisconsin idea, not only in their personal lives, but throughout their communities and their careers. Thank you very much. Sorry, I'm going to turn it over to Emily now.
Good morning. My name's Emily. I'm a graduate student at UW-Milwaukee. I've been studying anthropology for about 5 years, I'd say. I have to say it's a vast field with many topics to indulge in. I focus mostly on osteology and evolutionary anthropology, to mostly study bones. That's where I thought I belonged. That was until, on a whim, I applied to an archaeological field school through a university in Canada. The course was entitled Forensic Aviation Archaeology. Within the application, we were informed that only 13 students throughout North America would be accepted, selected to participate in the recovery of a World War II aircraft. Although it was a long shot and the only relevant experience I had was in osteology, I was accepted into the program. We weren't given much information about where we were going, what we were doing, or what to bring. I arrived in France with 12 strangers and took a bus to Normandy. From there, we drove to a cornfield, and we were informed that we were going to recover a soldier who crashed on D-Day. The site had been visited by DPAA agents about 5 years prior, but we were still skeptical about where the plane had exactly crashed. So as a team, we swapped the corn, mapped the site, and located the plane. On the 75th anniversary of D-Day, we were informed that the soldier was positively identified and returned home to his family. He was from Minnesota originally and had been studying journalism here at UW-Madison before he went overseas. A year after that trip, I got the opportunity to participate in another field school through the University of Wisconsin-Madison. This time, the team wasn't only made up of students, and it wasn't entirely done at the hands of the DPAA. This time, even though we had the same objective of bringing a soldier home, I could tell it was going to be a very different experience. The significance and expectation of this site and this mission seemed much grander than the year prior. We weren't just students there to learn, we were there to honor those who had fought for our futures. Once we arrived at the site, we removed a field of brush, mapped the site, and began to recover the remains from the Battle of the Bulge. In the field, the entire team was taught both academic and DPAA methods from experts in anthropology. We got the opportunity to meet and network with people from the DPAA and work with our future professional peers. We were taught how to dig and sift soil and shale, to draw soil profiles, use metal detectors, and how to map. Every skill I learned in the 3 weeks in Belgium will be applicable at another archaeology site and make me more prepared and hireable for future archaeological experiences. There's no better way to learn in anthropology, which is a field heavily set in methods and theories, than to actually experience what archaeology is like in the real world. It is different at every site and with every team. The objective may shift, but the priority remains the same. Archaeology isn't done for the sake of practice or the academia behind it. It is done to preserve the history of the people who came before us and still have a story to tell. I've learned so much from these experiences and feel more prepared to graduate into the professional field because of them. It means so much to me to be a part of this history. My grandfather was in the Navy and fought in the Pacific during World War II. He was on the USS Ozark, which participated in the invasion of Iwo Jima in 1945. The more I learn about these projects, the more I feel compelled to learn about his past. I want to continue his dedication and honor what he fought for in hopes that he would have seen the impact this project will have. These projects have given me the opportunity to walk the beaches of Omaha and follow the path Patton took to defend Belgium from Germany. I am so lucky to have gotten the opportunity to bring history to the present while continuing to learn and experience the world of archaeology. Thank you.
Thank you, panelists. This was not only informative, but incredibly important work that you're doing for the citizens of Wisconsin, but also the nation. I thank you for that. Questions from the Regents this morning? Can you talk a little bit about, I mean, this is such a unique program, and it seems that Wisconsin is at the forefront of this. Are there other universities that you're partnering with to try and assemble more of a rich, robust focus on this? Just give us a sense of how you're leading that.
So UW, or the university system, is unique in that we have all the tools from doing the historical analysis all the way to the biological analysis. So a lot of universities have witnessed what we've done, and they want to emulate what we're doing here. One discussion, we've been meeting with University of Washington. They are in the process of emulating what we're doing here, as well as University of Nebraska. Dr. Bill Belcher, who obtained his PhD here at UW-Madison, worked with DPAA for 20 years and has just recently retired and is now leading a forensic laboratory in Nebraska, so they want to partner with us in that aspect. So, yes.
And I would add to that that we have had student volunteers from other institutions as well. We're trying to be inclusive when possible. We have students from different institutions at the UW system and beyond.
Can you give us a sense about funding? You know, there's obviously extensive travel involved. You use fairly sophisticated tools and high impact machinery. Just give us a sense of how this is, underwritten.
So our administrative budget is, we do not have an administrative budget. We work on a volunteer basis. However, when we are going overseas, and this is one of the difficulties, is DOD funds the recovery missions, and they only fund that portion of it. They don't fund any scouting or allowing us, as Greg stated earlier, to be able to go over and scout ahead of. So we're going by their documents from 5 years ago. And it presents many issues where we can lose a number of days with that. What we're trying to do at this moment, where a number of representatives up at the Capitol is trying to obtain a bill that will allow us to become autonomous from the Department of Defense. One of the issues with that, they're seeking $180,000 to perform one to three recoveries per year, plus 10 plus recovery or historical reports to give closure to families for cases that are not probable. With that, it would allow us to become autonomous from DOD. DOD does not allow us to work with family members on cases. One of the things that family members have are very important documents that can actually lead us further into an investigation. Also, DOD does not allow us to do the biological analysis. The problem with that is we can do the biological analysis in less than a month. It's taking DOD 5 to 16 months to do the biological analysis. How many family members or even eyewitnesses pass within that period of time from World War II?
Yeah, thank you. Questions of the Regents? Regent Bechtel, thank you.
Yeah, I don't know if you can answer this, but just as I'm sitting here, I'm just kind of curious how U.S. numbers of MIAs might compare to other countries. So if we think of World War II and the vast number of Russians that were lost, Germans, and Japanese as well, how do we fare in terms of other countries in terms of the number of MIAs?
If you look at the numbers, we're fairly low compared to Germany, Russia especially. Just because of the number of losses and civilian losses as well that they really can't account for. So we're fairly low, but 83,000 is compelling.
Oh, yeah.
And with the DPAA have taken the lead on it, they were recovering roughly a decade ago, roughly 44 MIAs per year. With 83,000, our goal is to end people's positions in this recovery. That would be one of the ideal outcomes. And that's why I think academia can really enhance this, as well as they see that now with this development. Thank you.
Any other questions from Regents this morning? Regent Mueller.
I was just going to say, we can't give a standing ovation to the soldiers who lost their lives, but we certainly can to you, and I hope that happens in just a moment.
I appreciate that.
Regent Tiedemann.
One final question. Can you speak to any of the local partnerships that you make, since any of the interactions that you have with, I mean, for previous cases, not just ones that I've been involved with, but previous cases such as the Fazekas case in 2016, 2017, or visiting the cemeteries where the names of these individuals that you've been involved with are?
So to give you kind of a feeling of what we deal with on a day-to-day basis in the field, the eyewitness, Mr. Kush, who was 8 years old for the Fazekas case, witnessed the crash, and it had impacted him for his whole, to this day, his lifetime. When we were on site, he was in his mid-80s. He witnessed the crash. He believed he retained the soils where the crash site laid, but a train line had come in, and the road that the crash site was north of had moved north, so it was actually on the south side. He was very displeased with that once we determined the site. He was close. He was an eyewitness, 100 feet away. However, he kept that plot of land because he always wanted to have that individual recovered. For 80 years, he held that land. So when I tell people, it hasn't just impacted our nation or our family members, it has also impacted the eyewitnesses. Every day they allowed us to come over and eat underneath their patio, underneath the shade. We were in the middle of a cornfield. Sun was on us all day long, raining. We were up to the water and up to our ankles. And the students and the staff and the faculty continued to push forward. However, every day during lunchtime, they would come out and they'd give us a tray of chocolates. And it was very kind, and we thought, you don't need to do that. They said, no, we need to do that. And we had asked, and they said, this is what the soldiers gave us when we were liberated, was chocolate. So they gave us chocolate every day so you can understand how that impacted them. Ardennes Cemetery in Belgium, there are the tablets of the missing. There are thousands of missings on these tablets. When an individual is found, there's a rosette placed to the left of their name. Of all the 1,000 missing, there are 12 rosettes. UW found 2 of those rosettes. So it's a little impactful when you go there and you witness it, and then when you come home and the family members, show up. I mean, everybody can. It's emotional. It's honorable.
Everybody cried like a baby when they saw it.
But UW has been leading this charge, and we continue to keep pushing.
Sam, Alicia, Emily, Greg, Charles, Tori, thank you. Incredibly informative presentation. We thank you for your volunteerism, your research, and your service. The theme of today's meeting is incredible research. To explain, President Cross would like to say a few words. President Cross.
Well, I have a number of comments here, but before I do, what we attempt to do at least twice a year is expose some of the things that the university does in a way that helps inform and educate board members and all of us. And this is obviously close to Veterans Day. So this work that Tori and this team have been doing, we think illustrates not just how the university integrates the different kinds of academic experiences with the application of that and how that impacts lives, but how these kinds of things improve all of our lives. And so this noble and honorable work from a veteran, I want to say thank you. And this speaks so highly, I think, of our commitment as a university to fulfill this incredible mission statement that has been so eloquently expressed by our forefathers. Just amazing. So I salute you. All of you outrank me anyway. So. Particularly the captain from the Army, cheapers. This central theme is in today, if you study the All in Wisconsin efforts, we're building this all around the word in. And so our word today is incredible research. And we're going to see more of this in the coming months, but what qualifies as incredible research? You're going to get a little window of that today. And too often, I don't think we spend enough time focusing on those things outside of teaching. And obviously, teaching occurs, instruction occurs as a part of research. But this morning, we're going to hear from 3 UW institutions, Milwaukee, Oshkosh, and Madison, who will each provide an overview of one of their research initiatives or projects. And I think you'll be impressed. And they're just an exposure of some of the things we're doing. We do need to help the public and businesses, communities, legislators, and others understand the incredible scope, depth, and impact of the work that's done on our campuses every day. So we will tell the UW research story today and keep telling it going forward. At future meetings, we will continue to highlight some of the most fascinating, impactful, and promising research that our campuses conduct. Why are we doing this? Why is research important? More specifically, why is public university research important? So let's start with some historical context. During and after World War II, most of the nation's federal research and development was performed by big national laboratories and industrial research labs, supported by the likes of Bell Telephone, Xerox, Hewlett-Packard. But many of these great industrial labs have shut their doors, and governments and businesses have turned to universities to fill the gap. Today, universities are the primary sources of U.S. research, discovery, and innovation. Let me repeat that. Universities are the primary source of this. Every day, we benefit from discoveries made or knowledge that originated in university research, things like antibiotics, computer devices, and smartphones, laser eye surgery, weather satellites, ATMs, and yeah, even sonic toothbrushes. Our UW researchers, and that includes faculty, staff, and students, are producing research that improves our health, grows our economy, and enhances our day-to-day lives in profound ways. University research also plays a significant role in regional and national economic development. Academic research makes our universities powerful innovation hubs, fostering startups, business incubators, and technology accelerators. We know, too, that engaging in academic research enhances student skills and employability. You saw some of that earlier. The hands-on experience of solving challenges through research can provide a real competitive advantage in finding high-paying jobs. That's why undergraduate research is considered a high-impact practice, and it's a priority we are actively encouraging throughout the UW system. The story we need to tell more clearly and more widely is the enormous value and benefit our research efforts offer the people of Wisconsin and beyond. There are 115 universities in the U.S. that can claim the prestigious R1 or Research 1 rating from the Carnegie Classification of Institutions of Higher Education, the national organization that ranks research institutions every 5 years. Wisconsin is now home to 2 R1 universities, which is particularly noteworthy for a state our size. UW-Madison, the UW system's flagship, has been on the list since it was started. It is an undisputed research powerhouse with roughly $1.2 billion in annual expenditures for research across all fields, about half of which comes from federal awards. Let me repeat that, $1.2 billion annually. Ask Chancellor Blank what discoveries UW-Madison has been involved in, and she could keep us here through next week, if not next year. She might do that anyway. And it's not just Madison. UW-Milwaukee joined the elite R1 list in 2016, an incredible accomplishment because they also have an urban access mission. UW System's comprehensive institutions are also enhancing their research agendas, not only in applied research that can lead directly to company and job creation, but also in research that is foundational to further discoveries. Every single institution is engaged in productive research activities in ways both big and small, and our students, our businesses, and communities all benefit. But here's something to consider. According to a new report from the Nonprofit Information Technology and Innovation Foundation, the U.S. has fallen to 28th among major industrialized countries in government funding for university research, dropped considerably. With the 12 leading governments investing more than double what the U.S. invests in research. The report also noted, and I quote, national economies increasingly compete on the basis of innovation and in the race for global innovation advantage. The U.S. will continue to trail countries that have made support for university research a key part of their national innovation strategies. While our public research universities used to be the envy of the world, many foreign universities have gained ground. End of quote. So as we celebrate our incredible research initiatives and successes, yes, I will probably overuse that word, we should also consider the UW System's role in enhancing our research enterprise and bolstering the economy. Following today's campus presentations, we will have a panel discussion, and we will listen to these presentations. As we listen to them, I would like us to think about a few questions. What can we do to increase support for research, for funding? How can we form more productive alliances between institutions, businesses, and others to facilitate increased research? How can we strengthen our research culture? How do we create a culture where research is valued, if not valued, treasured? I would like to close with one last point. In the UW system, we are actually required by statute to perform this work. In 3601, our statement of purpose and mission, the university is explicitly charged, and you heard Regent Tiedemann quote some of this, to develop human resources to discover and disseminate knowledge, to extend knowledge and its application beyond the boundaries of its campuses. It's a noble mission. I hope our dialogue today will enhance our understanding of the truly incredible scope and significance of the research that is being done on our UW system campuses. As noted, we have 3 institutions presenting today, UW-Milwaukee, UW-Oshkosh, and UW-Madison. So UW-Milwaukee will start this off, so please join me in welcoming Dr. Doug Stafford, Director of the Milwaukee Institute for Drug Discovery. Doug?
Thank you, President Cross, for that introduction. Thank you for inviting me to be here. It's truly a pleasure to represent UW-Milwaukee. Thank you, Chancellor Maloney, for having me here. to talk about one of our programs at UWM. And while we do a lot of research on campus, this is one that I'm particularly fond of. I'm director of the Milwaukee Institute for Drug Discovery. The Institute was established a number of years ago to put a little bit of an organizational structure around faculty research where we've had a historical strength on our campus, and that's medicinal chemistry, or the chemistry involved in making medicines. There are a number of faculty who have had a common interest in this type of research, and so we decided to create an institute. And really the objective of the institute is not to tell faculty members what research to do, but really to support them and complement their research to move discoveries along the value chain towards being a pharmaceutical that you might be able to see in your Walgreens store that would be prescribed. And so what the Institute attempts to do is create additional sources of financing, to provide some expertise on the later stage aspects of drug development that are outside of the normal scope of academic research, to provide infrastructure, and also to think about what the next steps are as far as licensing technologies to firms that may be able to bring that to the market. I would also like to acknowledge that a tremendous amount of support for our research was actually provided by people in this room. If you may recall, in 2013, our campus was awarded an incentive grant of $3 million. The Institute for Drug Discovery is the principal investigator on that. And while the resources provided by that incentive grant serve many different constituencies across the scientific enterprises in our region, the Institute is a major beneficiary of the resources that brought to us. And also, the money that was provided by the UW system was complemented with a private sector grant of $1.13 million from a Japanese instrument manufacturer to really provide a world-class suite of instrumentation for us to do the work. And so not only do we have the historic intellectual capital on our campus to do this kind of work, we now have the tools to do it. And you'll see in a little bit some of the students and faculty involved in really the benefit and the quality of education, quality of research that's being done by virtue of the support that we've gotten. So thank you very much for the support historically that we've gotten for our program. So let's talk a little bit about drug discovery. And President Cross, you really teed this up quite well, because you're thinking about, isn't drug discovery something that's done in the pharmaceutical industry? Well, historically that's true, but you can see from an article that was published in Nature a number of years ago is that the traditional drug discovery model is ripe for reform, and where academic institutions are really now at the center of this. And some quotes from this article: candy drug manufacturers are increasingly outsourcing early stage drug development, including trials to academia and small companies. And academic researchers are in the heart of drug discovery. Well, let's think about that for a little bit. If innovation needs to occur and in developing new drugs to treat unmet medical needs needs to occur, is that best done in a 30 or 40,000 person organization in many places around the world? Or how about a nimble academic group of really talented, clever people going to the whiteboard, drawing out a concept, going into the laboratory, doing some experiments and seeing whether something can work? That's innovation. And innovation happens in academia. That's what we do. We create knowledge, we come up with ideas. And in the drug discovery world, that has really become the way it's done. And so there's an equilibrium, which has somewhat happened over the last couple decades, in the continuum from discovering an idea to having a drug on the market, on where the various activities are done. And really the front end of that, as these quotes show, the front end of that is the discovery, the innovation really happens in academia. And I'll just quote one study that was published towards the end of last year. A group looked at all the drugs that were approved by the Food and Drug Administration from 2010 to 2016. And there were 210 new drugs approved. So they wanted to look back and say, well, where did these come from? And the research showed that every one of the 210 drugs approved by the FDA during that time frame received NIH support in academic laboratories. So it's not just the concept here that, well, we think maybe it's a better idea that academia take on this role and responsibility, but the results are there. And so academic laboratories like ours and like the 100 or so academic research centers around the country are really playing now a really significant role. So what is drug discovery? I think most people understand the end of the process where you look behind the counter at your Walgreens and you see all of these white bottles on the shelf, but that's really the end of the story. Where we participate is at the beginning of the story. And so I just want to talk a little bit about the drug discovery pathway, because I'm going to come back to that when we describe some of the programs. And after we go through this, I'm going to describe 4 of the programs that we do in our institute, just to give you a flavor of the diversity and how we approach problems. So at the beginning of the process, there's clinical knowledge. And so for drug discovery to really be useful, there's an unmet need. What disease is not being well treated with the current standard of care in pharmaceuticals, whether it be in cancer or psychiatric disease or infectious disease? So clinical knowledge leads to trying to understand a drug target. What is it about the disease that is different, that might be able to be a target for a drug? And the lock and key analogy here it always works well, because the target might be a lock, and I try to identify a hit, like some sort of a chemical compound, which would be the key, that we can put into that lock to either turn it on or turn it off. And so this is really the front end of the process, is understanding a drug target and the hit. And drugs do pretty much that. They'll either turn on or turn off some function of a cell. Once we identify a hit, that's really not a drug. There's a lot of chemistry that goes into this to optimize the compound. So for example, the compound, it may be desirable to take it orally, or for a neuropsychiatric condition to get into the brain, or for other indications not to get into the brain. So medicinal chemistry does that form of optimization so that a molecule that interacts with a target can actually be a drug, and also to engineer safety aspects. After a drug is optimized, there's an awful lot of animal testing. There's typically a rodent model, a mouse or a rat model for virtually every disease. Also, you can evaluate the safety of the compound. This is all actually required before a product is allowed to be tested in human beings. All of this data has to be summarized, presented to the FDA. If the FDA feels that there's not an undue risk to human beings and it looks like there's potential pharmacologically for the compound, you'll be allowed to do various phases of clinical testing. If that all goes well, then it goes to the shelf in Walgreens. This is an exceedingly difficult enterprise. Failure most often occurs at any particular stage along the way. On average, this process may take 15 years from the initial concept to the approval, and depending on what you read, can be hundreds of millions of dollars to over $1 billion to get this process done. So this is the overall process. What I just want to show is, well, we don't do it all. As an academic laboratory, we focus on the middle part of this. We start with the drug target and do an awful lot of chemistry, and then understand the potential value of the drug in the animal models. At that point in time, if the molecule or the drug concept looks viable, then it would be passed off to others to do the large-scale clinical testing, which may involve global infrastructure to do clinical trials, regulatory manufacturing, which is really outside of the scope of kind of the innovation academic research that we do. But it also brings up a point, too, is that if there's going to be a handoff here from the academic side to the commercial side, intellectual property needs to be established. For a pharmaceutical company to come in or some other group to come in, there has to be established value. And so we work very closely with the UWM Research Foundation to patent inventions that occur along this process, and we'll talk a little bit some of the outcome of that patenting activity. So this is the algorithm, but what I'd like to do next is to give you a sense of kind of who's doing the work and where, because I think it'd be very illustrative, not just to have me talk, but to hear the passion and the excitement that people have in working in our laboratory. If you could show this.
UWM has a history of work in the area of drug discovery. There were a sufficient number of people that we needed to form a group.
The Milwaukee Institute for Drug Discovery. Maybe we will listen to me. There we go.
Has a history of work in the area of drug discovery. There were a sufficient number of people that we needed to form a group.
The Milwaukee Institute for Drug Discovery, what we call the MIDD, was established about 5 years ago, and part of the role of the MIDD is to provide the resources for people to work across their disciplines to create new drugs.
The discoveries that we are doing in the lab, our goal is to improve the quality and quantity of life.
We would love to be able to prevent the problems before they happen.
We try to use these targets in order to develop new compounds for cancer, for depression, and for asthma.
Infectious disease, both viral and antibiotic-resistant disease, neurological problems like alcoholism and anxiety and pain.
Depression as well as schizophrenia. I think we'll have drugs, to be able to treat those diseases.
We have established the Shimadzu Laboratory, which is a world-class analytical chemistry facility.
This is the state-of-the-art instrumentation lab.
Not all universities are privy to some of the instruments and technology that we actually have here at UWM.
I mean, we're just light years better than we were before. Always before we had to send the compounds out. But now, with this really phenomenal facility and the other equipment in the department, we can do this just as well as any drug company.
The real strength of the MIDD is the specific people we have. We have a really special group here.
When I have a problem that I can't solve, I can look across the bench top or look behind me in the office, and there's someone there who can help me answer that question.
Students get this wonderful opportunity to work with nationally and internationally recognized faculty.
The biggest impact that my research has is in training the undergraduates, training the graduate students, who are then going to go off and make their own discoveries.
They're able to work across disciplines, and so they're able to participate hands-on in many areas of research that wouldn't be possible without these cross-disciplinary programs being in place.
You're making molecules that really have the potential of being able to treat patients and learning organic chemistry at the same time.
For pain, we have a very active program that's been supported by the National Institutes of Health for some time.
We can make compounds to get rid of all the side effects that you would get normally from Valium, from addiction, tolerance, withdrawal.
When we think about better cancer therapy, our drug discovery programs are working on more targeted therapy for effective cancer treatment with reduced side effects.
Being able to work on a topic that will eventually go into research, will get further results, and could potentially change people's lives is really rewarding.
People ask me what projects I'm working on, and I tell them I'm working on asthma, and then they tell me they have family members or they have friends who are really going through this problem, and so they kept urging me on to work hard to come up with something interesting that would help them. We
are developing an oral dosage form that avoids the use of inhalers that we know have significant drawbacks, as well as this strategy avoids the use of steroids.
We're advancing in preclinical trials really rapidly, and I think that puts us ahead of many other groups.
So when you add all of this up, our faculty are working on not just interesting science, but impactful products that'll affect people's lives.
We're making real contributions that are going to help people, I think, for a long, long, long time.
It's a great bunch of people. I've heard people say, how great their jobs are. Working with this bunch of people is really quite rewarding. So what I'd like to do is move on from kind of the big picture, the 30,000-foot picture, and really zero down on a few projects that can give you the flavor of what we do, and the word impactful we use a lot. And most of the faculty I'm going to describe here are all in the Department of Chemistry and Biochemistry. The first is Dr. Shama Mirza, assistant professor. She's working on a drug, on a disease called glioblastoma. And glioblastoma is a very difficult brain cancer. It's a primary brain cancer, so it originates in the brain. One doesn't have to be a radiologist or an oncologist to look at these pictures and understand how profoundly dangerous this condition is. Many may be aware that this is the cancer that took Senator John McCain's life last year. It's a very difficult cancer to treat. Median survival is only about 15 months after diagnosis, and recurrence occurs virtually every time, even if there's an initial cure. So within the last 25 years, even though there's been a lot of advances, really there has been no improvement in the survival in this disease. So Dr. Mirza uses a process called proteomics. So she's an analytical chemist who understands or studies proteins that are in cells. So this study is kind of straightforward. So she was able to get tumor samples that were excised from 10 glioblastoma patients and looked at those samples and analyzed over 600 proteins that are expressed in those tumor cells to see what's different. What's different between glioblastoma and a normal cell, or what's even different between various stages of glioblastoma. And lo and behold, there was one of those proteins that popped out. It's called acid ceramidase. And that acid ceramidase is associated with poor survival. The more of it that's in the tumor, the worse your prognosis. And also it relates to resistance to radiation therapy and chemotherapy. Well, as it turns out, there's a compound that's been known in the literature called carmophor, which actually binds to and turns this protein off. And so what we're able to do is grow glioblastoma cells in a dish. And so in this one study, she was able to compare the current drug that's approved to treat glioblastoma and compare that against carmophor and showed that this was 3 times more effective than the currently approved drug. So this is based on fundamental research, but with a very, very applied outcome, and that's to identify a new cure. Now, there's a lot more of that medicinal chemistry, and so when we go back to our algorithm, she's identified a new target. There's been now a lead that's been identified, and now more medicinal chemistry is being done to optimize this to the point where it can be a drug. I'll give you another example in cancer. Dr. Shehua Peng, who's an associate professor in our group, and is addressing the problem of side effects in cancer chemotherapy. I think most everyone knows that cancer chemotherapy is subject to many adverse effects. Not only do the therapeutic agents kill the cancer cell, they kill a lot of other cells. And so side effects like hair loss, gastrointestinal problems, and anemia, white cell loss are huge problems. So what Dr. Peng did is really took advantage of some interesting biology, and that is, can you create a drug, what we call a prodrug, that is only activated in the cancer cell but leave normal cells alone? And this little diagram tries to show that. So in an actively dividing cancer cell, metabolism is really revved up and produces some compounds that are different than a normal cell. And one of those compounds is hydrogen peroxide, or peroxide radicals. So what she thought is, can we engineer a drug that is actually activated by the peroxide in the cancer cell, but the drug wouldn't be activated in the normal cell? So, and she actually did that. So she designed drugs where essentially the warhead of the drug was activated only in the cancer cell, and the normal cell didn't care about it at all. And so once the drug is activated, it cross-links the DNA in the cancer cell, which is highly toxic, resulting in cancer death. Show you a little bit more data. So just example of 2 compounds that she developed, compound 2A and 2B. So in this study, human breast cancer was placed in mice. This is a standard way of evaluating cancer compounds. And tested a control compound against these 2 compounds, and after 6 weeks after transplant, again, the new compounds were exceedingly more effective in reducing the size of the tumor in these transplanted mice. She did another study where the currently approved drug that's approved for triple-negative breast cancer, if you're familiar with that, it's a particularly difficult breast cancer to treat. The currently approved drug was only 1/10 as effective as her new compounds. So again, a very novel strategy, taking advantage of the drug target, in this case, which is DNA, but coming up with a really novel chemical structure where the warhead only goes into the tumor cell. It's another one. Here's a problem I think most everyone in Wisconsin is very familiar with, and that's chronic pain and the use of opioids to treat chronic pain. There's some statistics here from the CDC as far as the number of Americans that have died due to opioid overdose. This is not a national problem only. This is a Wisconsin problem. In 2017, there were over 900 overdose deaths associated with opioids. That number came down a little bit last year, but it's still an overwhelming problem in our state, and I know there's a lot of work being done in our state to deal with this. We're dealing on the chemistry side, but when we think about opioids and pain, there is a reality here in that people have pain. It's estimated that 11% of adults experience daily pain, so it needs to be treated. And so opioids can be extraordinarily effective in treating pain, and the statistics are 191 million prescriptions in 2017. That's an awful lot of opioids, and are needed. However, about a third of those prescriptions, it's estimated, are being abused. So there's a significant problem here in the use of opioids, and so can we address the absolute profound need to treat pain, but again with a different strategy? And so we use medicinal chemistry to develop drugs for a receptor, okay, or a target, a drug target. In this case, it's called the GABA receptor. And the GABA receptor is really well known because it's the target for Valium and barbiturates, propofol, well-known pain-relieving compounds. However, we know that these have many adverse effects. They are addictive. Tolerance to the pain develops. There's sedation that occurs, other effects. So can we design a drug that goes after this, or that interacts with this GABA receptor, but we tease apart the adverse effects from the desirable effects? And our medicinal chemistry expertise allows us to do that. And I'll just give you, again, a little bit more data. So this is a compound that was developed in Professor Jim Cook's lab in our program by graduate student Dan Knudsen, DK. Developed a new drug where he specifically looked after a subset of these GABA-A receptors. Extraordinarily clever work, where he came up with a compound. Here is an animal study. This was done by our collaborator, University of Belgrade. Evaluated this compound in a rat model of pain, and lo and behold, it was about 85% more effective than control compounds that are used to treat pain. So again, we can use chemistry and understanding drug targets to create first-in-class drugs that are highly effective, but also reduce the adverse effects and absolutely reduce the reliance on opioids and more addictive drugs to treat pain. So I have one more, if I may. Professor Alexander Arnold in our group studying asthma. And really the problem here is, can asthma symptoms be controlled without steroids? Most people are familiar with inhalers that are used for asthma control. Most of those contain some form of steroid. However, it's known that more than half of patients with moderate to severe disease, even using these drugs, do not have their symptoms under control. So yet again, there's an unmet medical need in the treatment of this disease. And so disease is resistant, people don't use inhalers correctly, the drugs often don't work, and for the most severe patients who need biologics, it's extremely expensive, up to $30,000 or so a year. So the solution is, can we target a new target for asthma? And lo and behold, it's the GABA receptor. We just talked about that in the brain. Our group was part of the discovery that these GABA receptors are also found in the lung. And so what we've been able to do is repurpose about 50 years of knowledge in developing molecules that ping the GABA receptors, but now in the lung. And so we've changed the chemical structure to avoid brain exposure. This is now a fundamentally new mechanism for treating asthma that does not involve steroids or other muscle relaxant drugs. So the last piece of data here is that we've shown extensively in animal models, there's actually a mouse model, mouse can get asthma. We've studied extensively in these programs that the drug not only reduces the underlying inflammation of asthma, but they relax the constriction of the airway that makes it difficult to breathe. So part of the novelty here now is there's one drug that does two things. It's anti-inflammatory and it reduces the constriction of the airway. And it's also effective in disease that's resistant to steroids, which is also a major finding here. So just to wrap up, to get away from the science a little bit, I just want to talk about the impact. And President Cross talked about a lot of these as far as research, education, outreach, and entrepreneurship. Our group has generated pretty good federal funding to support our work. The scholarly output of that, I think, is rather remarkable. There have been over 300 publications in the scientific literature on the work I described and some of the others. On the educational side, about 40 graduates with PhD degrees have come through this program. Actually, the odometer is continuing to turn. There'll be 42 in another month. These graduates are going into the industry. One of our graduates is now a reviewer at FDA, who's actually reviewing drug applications for approval. We have people going into academia. We have people going into the top levels of the biomedical industry, the pharmaceutical industry. The people are being trained using world-class instrumentation. What you saw in that video and what was supported by this room is really making this happen. So we're putting people in the workforce who are really right at the top of their fields. MS degrees, BS degrees. There was the mention of undergraduate research. As an R1 university, we are able to connect our students with very high-level research at the undergraduate level. And in fact, it's a requirement in our chemistry department that undergraduate research is part of your degree. So on average, there's about 40 individuals per year who are coming through the labs, getting that hands-on experience. And they're not washing test tubes. They're in there, they're doing experiments. Students will come through there after rotations, being co-authors on scientific articles. Some have been co-inventors on patents. Outreach is important for us. I start to plot this out as far as where our collaborations are, and it's too complicated. But let's just say there are scores and scores and scores of collaborations that we have around the world. The drug discovery algorithm that I showed is really complex. No single individual or no single lab has all the skills necessary to make this work. So we need to collaborate, and we do this extensively. We also have a number of service agreements because that laboratory that you saw is expensive to operate. It was mighty expensive to buy, but it's also expensive to operate. So we have a number of agreements with industry that provide the resources that really assure the sustainability on that lab. And I know I was pushed very hard when we got the grant to say, well, how are you going to sustain this? Well, we have. And finally, on entrepreneurship, which is a huge topic on our campus, from our group, there have been 20 invention disclosures and 21 patents either issued or pending. That's resulted in 5 license agreements, and very recently, some of those licenses have now gone into spin-out companies. And so there are now companies that have been established by our faculty, or we have supported significantly in order for the technologies to go to the next step from the academic laboratory into further development. So finally, just to wrap up, I think our program is really quite impactful. I use that word a lot, but it is. And we look at these pictures all the time because it's one thing to go in the laboratory and try to solve a problem, but to get through those difficulties, you look at the kid with cancer or the asthma patient or the person with pain or depression. These are all things we're working on. And these are things in our community. In Milwaukee, the prevalence of asthma is almost twice the national average. We know that opioid epidemic is a problem in Wisconsin. And our public university is working on that. Thank you.
Thank you, Dr. Stafford. Great update on your research and discovery activities and your impact in Milwaukee. Questions from the Regents for Dr. Stafford? Okay. Well, again, thank you very much. All right, moving on to item number 8. Our next presentation is from UW-Oshkosh. It's all about Hive Central, a partnership to help address high bee mortality rates in winter. Incidentally, for those of you that were at the All in Wisconsin event in Oshkosh, we got to see it demonstrated firsthand. It's quite impressive. This time I'd like to welcome the student researchers and other members of the project. Following directions before I've given them to you, please join us at the table. We're thrilled to have you here. I'll turn it over to Arjun to start the discussion. Good morning.
Good morning. Do we have the slides up here? Oh, that's not mine. There we go. Perfect. So this isn't a bait and switch. I want to thank Chancellor Levitt for the collaboration with having WISIS working with UW-Oshkosh as well as UW-Superior. First, I'd like to thank President Peterson, the board, for the opportunity to present today, and also thank UW system colleagues, President Ray Cross, chancellors and provosts, and all our UW system friends and colleagues, and of course our distinguished guests. Ray, given your recent announcement, I wanted to thank you for all the support you've provided WISIS generally and myself personally. It's been an honor to working with you. Of course, I understand you'll be continuing for a little while until you find your successor, but I wish you the best on your next endeavors. We appreciate all of the keynote addresses at our annual conferences, hosting student ambassadors each year at the President's Residence, and your service on the WISIS Advisory Committee. Ray even provided technical advice to some of our inventors. As an engineer, I'm sure he couldn't resist. So thank you. We really appreciate it. It's a privilege to work for WISIS in supporting UW system. There are many great stories to tell you about what's happening in the UW system, and you can read many of them in the annual report that's being distributed that you should have in front of you today. And for those of you that didn't get a copy, you can get it on our website, www.wisis.org. The specific story we're going to tell you about today is one that highlights the power of UW system to bring together people and ideas from across the state. You've already heard of a lot of the great research that's going on, and you can see from some of the stories, the collaborative nature of that. It's no secret that UW system faculty, staff, students are engaged in exciting and valuable research. One measure of that for WISIS is invention disclosures. This is when someone from our campus communities brings forward an idea that they think can have social or commercial impact on society. And usually, each invention disclosure is an expression of a unique, novel idea. So really think about that. I mean, we're getting all these great ideas every day. One of the things that we learned at WISIS 5 years ago as we started to look at our numbers, a third of our invention disclosures come from students. So that's really exciting. In the past 5 years, we've collected more than 300 invention disclosures, including one technology from UW Superior that these students will be talking about shortly. With the support of UW system and the relationships that WISIS is building on campus and between campuses, these disclosures are growing. In this fiscal year, we've already collected, show up here 26, but since I did this slide, 30 invention disclosures, putting us a great pace to potentially have a record year. And as you can see from that, that's in our first quarter, and that in 13-14, we're matching an entire year's output. So you can see that our regional comprehensives are really doing a terrific job. They're just a lot of great research and exciting work that's going on those campuses. So the growth we are seeing is all about building connections. We've worked hard to bridge the distance between our people and campuses we serve across the state through a regional associate program, which puts WISIS staff on all 11 campuses on a regular basis. We further maintain our footprint through student research and innovation programming and our WISIS Ambassador program that President Cross has so helpfully supported, which employs students to build deeper connections on campuses. We've also been aided with great partners who share expertise, assist in building programs, and support our mission to inspire Wisconsin innovation. The story you're about to hear is a culmination of these building blocks that stretch from Superior to Oshkosh. It would not be possible without the creativity of inventors, UW Superior biology professor Ed Burkett and retired staff member Kenneth Rehala. It would not be possible without the expertise and collaboration of UW-Oshkosh's Colleen Merrill and the Center for Entrepreneurship and Innovation. It would not be possible without the support of the chancellors of both of these schools, UW Superior Chancellor Renee Wachter and UW-Oshkosh Chancellor Andy Levitt, who, by the way, is a member of the WISIS Advisory Board and has been very helpful in that regard. And as a side note, I just found out that Chancellor Wachter is a beekeeper. And of course, this story would not be possible without the passion of 3 UW-Oshkosh student entrepreneurs, Jessica Tarter, Parker Schmidt, and McCall Hill. This story is an example of the collective power of UW system and what we can accomplish when we work together. Thank you.
So when I started as the SBC director about 7 years ago, I was not prepared for student demand. So we created the Center for Entrepreneurship and Innovation to engage with students. And we do all the typical things. We do the 90-second pitch and the business model contest. And we also, with WDC's help, run a seed accelerator every spring and summer. And that's awesome. And that was impactful. But over the past few years, I realized that there were so many students that were showing up, that were stopping by in our office, that wanted to be a part of the entrepreneurial spirit, but didn't have an idea. And all the programs we created were for those that already had an idea to vet out. So we started coming up with some creative ways to fuel their entrepreneurial journey. And one answer was WISIS. I approached WISIS in 2017 with a proposal with what if. What if we hired students to explore existing intellectual property? What if we taught them lean business development? What if we guided them through that whole research process and connected them to manufacturers, mentors, resources in the community? Would they mesh as a team? Would they become passionate about intellectual property that they didn't create? And would they create an economic impact in our region by launching new companies? Well, let's see what happened.
I saw the job posting. I kind of just applied on a whim, not knowing what I was getting into.
We went through the interview process, and then I'd say about a week later, me, Jess, and McCall met in a room as strangers to talk about the beginning of the program.
Yeah, so we didn't know each other, and so it was really interesting seeing all of us come together over this passion for entrepreneurship and then really move forward with our business project. We each made market feasibilities on which one we thought would be the best to market.
And we thought that the Bee Shield had the most market potential.
The purpose of the Bee Shield is to prevent wind from entering the hive while still allowing condensation to escape.
So what made us choose the Bee Shield is that we realized there's such a big problem in the beekeeping industry, and that's keeping your bees alive. Death rates can be as high as 80% in places like Superior. So what the Bee Shield does is it creates an internal environment which allows them to retain more heat and increase their chances of survival.
We're really targeting the hobbyist beekeeping community, which comprises of over 1 million hives.
We started Hive Central, our company, around this product, and we've just been marketing it and trying to find a manufacturer. We've been modifying the design with the engineering team here on campus.
You know, you think entrepreneurship is, oh, you pick the product and you sell it, and it looks like a straight line. It is so up and down all over the place. In general, we kind of have different lanes that we tend to operate in. So for example, I'm managing most of the work that we're doing for the $25,000 grant we're doing.
I am the head of marketing.
My role is really working with the physical product itself.
We figured out a way to complement each other's strengths and kind of hide each other's weaknesses. We really just figured out what we're good at, and then we put each other in places to succeed.
Dr. Burkett is really funny. He is so interested in the bees and just working with his apiary that he kind of just gave us the whole business side of it. And so it's really been a unique partnership in the sense that both of us are doing what we want and then coming together and creating the Bee Shield.
So the professor's original product was really great. The concept was really great, but we decided that we wanted beekeepers to be able to attach it to the sides of what's called their bottom board. So what we did is we made iterations to the product.
We needed to modify the attachments. We decided that the professor that we worked with in the engineering team brought the idea to 3D print it, and we were all for it. It took 70 hours to 3D print our product in 2 different parts, and then we had to glue it together.
And funny thing, when we went to the inventor and told him about our changes, he actually liked the changes, which was very favorable for us.
It was super exciting going to Superior and seeing his apiary. It was also very interesting seeing his point of view of the design changes that we made because this is his baby.
It was great talking with him, learning about bees. We learned so many interesting things that Jess can use for marketing, but really just going up and having his support was probably the biggest thing for us. The support from the CEI, WISIS, and the inventor himself has just been phenomenal.
We have experienced an overwhelming amount of support. They have given us so many mentors and resources that have allowed us to be where we are today. Oh no, I didn't know anything about bees.
had no idea about bees.
I knew nothing about bees.
I have learned so many fun facts about bees. It really excites me.
I've learned a lot about bees, let me tell you that.
Oh, I've learned a lot. This winter, we're really focusing on bringing the Bee Shield to the market.
We're doing a beta run. So our plan this winter is to get this into as many hands of beekeepers as possible.
We want to launch in September, and we want to keep continuing to give great products each winter.
4 to 5 years from now, we want this to be a tool in every single cold climate winter beekeeper's toolbox.
So there's approximately 1 million beehives in cold winter climates. That includes Wisconsin, Montana, North and South Dakota, Minnesota. Big market.
I'm allergic to bees, so we have an EpiPen on site in case, you know, something wild accidentally happens.
So you just saw how we got started, but it definitely wouldn't have happened without the Alta Resources Center of Entrepreneurship and Innovation with Colleen and Dan Brosman. They have been amazing mentors throughout this amazing program that we've been in. As we started, it was more of a research-focused program, and as you saw through our video, it turned into a life-changing opportunity for us. One of my favorite parts is that I'm simultaneously applying what I'm learning in my classes to my career on a daily basis, which is super exciting for someone and highly motivating as well. Colleen and Dan have also answered the annoying amount of questions that we have had for them and only have opened their arms to us. If they didn't know the answer, they would always find a mentor within our area that knew the answer that we needed. And through these mentors, we've created relationships with many individuals throughout the Fox Valley area with many different backgrounds that have only helped our success.
So we're talking about research and the experiential learning and how it's impacted us. And I can tell you the firsthand experience of how beneficial it is because I've been on the other side. I've had the typical business internship where I'm doing data entry and running the same reports day in, day out, and being the kid that runs to the printer to get all these different copies. So this has been extremely beneficial to us. And so thank you to UW-Superior, thank you to UW-Oshkosh, thank you to WISES, and most importantly, thank you to Colleen and Dan at the CEI because none of this could have been done without them. So like I said, none of this could have been done without them, but there needs to be more programs like this because this has evolved our perspective tenfold.
And so through this UW-Oshkosh Center for Entrepreneurship and Innovation, as well as the UW Idea Advanced Seed Fund, we've been able to understand the value of research and experiential learning and be able to apply to our own lives as well as our business. So that's why the next step for Hive Central is to run quantifiable tests on the Bee Shield to understand its true effectiveness. Thank you.
So McCall, have you had to use your EpiPen yet?
What's that?
Have you had to use your EpiPen yet?
God, no.
Well, for those of you who were not at the All in Wisconsin tour, it was curious the amount of information and knowledge that President Ray Cross has that relates to bees. He was manipulating the prototype right where it was at, and I think all three of you were saying, "Who is this guy?" It was impressive and astonishing at the same time. With that, questions for the panel? Yes, Regent Walsh.
So I am one of those backyard beekeepers. I would love to try out one of these, just making a pitch for our gang. But you are correct that there is quite often a winter die-off. We lost both of our hives last winter. And so I think what you're doing is going to have a huge impact. I mean, it seems like a very narrow product, but in actuality, I think the experience you're getting from this is so broad. Do you feel that it has changed your trajectory of what you're willing to do with your degrees? Were you previously looking to go work for a large company and now you're thinking differently about it? How is that cycling through?
Yeah, so me personally, I just thought, okay, get a degree, find a company, get a lifetime job, and bada bing, bada boom, that's it. But through this program, I've learned that I just need to take the step and get out there, and I can honestly do whatever I want to do if you put your mind to it, and that's exactly what this program taught me.
Yeah, and I'd echo that. I think through the CEI's accelerators and incubators, as well as the Idea Advanced Seed Fund, has really taught me and us, I'm sure, that it's not about the money that you make, it's about the value that you add to society, and that's really what entrepreneurship and the CEI has taught me most.
There is value to be made, and I hope that someday when you starting your own companies, that you keep it here in Wisconsin. Just a pitch.
Other questions for the panel? All right, well, hearing none, again, congratulations. It's great to see you all. Our third presentation focuses on the Wisconsin Registry for Alzheimer's Prevention, the largest family history study of Alzheimer's disease in the world. To tell us more about it, here are two members of the Wisconsin Alzheimer's Institute, part of the UW School of Medicine and Public Health, Cindy Carlson and Sterling Johnson. Good morning.
Thank you. We'd both like to thank the Board of Regents and President Cross for allowing us to speak, Chancellor Blank for allowing us to speak in behalf of UW-Madison. So my name is Cindy Carlson. I am a physician in geriatrics, professor of medicine here at UW-Madison. I'm trained as a physician in geriatrics and also do research on Alzheimer's prevention. I came here from University of Michigan, but don't tell anyone, but came here in 1995 to do my internal medicine residency and then have never left. So we plan on being here a few years, and UW is such a great institution that we stayed. Let's see, do the other controllers somewhere? Thank you. I'm thrilled to be here with my colleague, Dr. Sterling Johnson, who will be speaking halfway through this presentation as well. So we'll be talking to you about our UW-Madison Alzheimer's disease research program, and we'll talk about some of the combined ways that we're trying to do research and also trying to make an impact throughout the state with our work. So these are our disclosures, which show that within Alzheimer's research, again, we work with the federal government, with NIH, the VA, partnerships with foundations, families, and also with industry in trying to develop the best tools to identify Alzheimer's early and the best therapies. So again, what we'll talk about today, I'll start by just talking about the impact of Alzheimer's in our state and in the country, and then talk some about the status of treatment and prevention of Alzheimer's disease and what our program's really doing to try to address those challenges. And then we'll just do a brief overview of what our program looks like here at UW-Madison, talk about our education and awareness efforts, which tie in directly to our research, and then talk about our research, which is really focused on early identification and prevention of Alzheimer's disease. So many of us are aware of these statistics, but the prevalence of Alzheimer's in the United States is increasing. So you can see where we are here in 2019. There are over 5 million Americans who currently have dementia due to Alzheimer's disease, and the number of Americans with this condition is expected to triple in the coming decades. So again, you can see from this slide that we're really at a critical point to address Alzheimer's prevention. So again, if we can really work to train our workforce to care for people with dementia because they're coming, but also try to blunt this increase so that we can hopefully prevent or at least delay the onset of Alzheimer's dementia in the United States. But even in Wisconsin, we know that there are over 110,000 individuals who currently have Alzheimer's disease. The number is expected to increase to 130,000 in the coming decades. It's the 6th leading cause of death, and while there have been advances in cardiovascular medicine, reducing the number of people dying from cardiovascular disease, the number of people dying from Alzheimer's continues to climb. We know that it's costly, so Medicare estimates are about $20,000 per person per capita related to Medicare costs, but at a recent meeting in DC, they mentioned that, again, most of the cost falls back on families and on Medicaid. So even these costs vastly underestimate the cost to our state, to our society as a whole. And as far as the other rippling effects, you can see here that while we have 110,000 people with dementia, there are 195,000 caregivers. Caregivers have their own health problems because they have chronic illness they don't address and suffer from more depression. So again, there's a rippling effect to this disease that our research team is really trying to address by trying to prevent the disease, trying to train people to provide good care, but also trying to do research on caregiver stress as well. So just to get us all on the same page and set the framework for our research, Alzheimer's dementia, or dementia itself, is a broader term. So again, it means cognitive behavioral symptoms. Again, you can see that this is all what we see in a person or in an individual. There are no tests listed here, but symptoms that are related to cognitive dysfunction that interfere with the person's usual functional ability, that represent a decline from what they used to do, not explained by a medical illness. So if someone goes in the hospital with a pneumonia, they might get acutely confused, but not something that's temporary like that. And that it affects their thinking abilities, at least several types of thinking abilities. But again, you can see all these symptoms that we see in the person don't really tell us what the cause of dementia is. So for example, as we were discussing last night, if you had a farmer who's normally able to manage the bookkeeping to buy and order supplies for a farm, and they can't do that anymore, then that's a change in their usual functional ability. Whereas if somebody never was good at bookkeeping and they couldn't do that at baseline, then that's not a change. But again, this tells us what we see in the person. But again, there's different causes of dementia. So again, this is the broader term. So Alzheimer's by far is the most common type, and Alzheimer's mixed with other dementias. So again, this is what our research team is focusing on, because that's going to have the biggest public health impact. So again, this is a picture of my grandmother who had Alzheimer's disease, was thought to be Alzheimer's dementia in her early 70s. At her 50th wedding anniversary, wasn't really sure what was going on at that event, didn't recognize people there. So again, what we look at in the person, so I just came from my memory clinic, this is what we're looking for in our clinics. We're looking to see what type of effect this disease has had on a person. But then in our research context, what we're trying to do is to see what's going on in the brain of that person. And we want to link these things together. So you'll see that theme in our work, what's going on in the person, and then what's actually going on in the brain that's triggering those symptoms. So in Alzheimer's disease, again, to give you a framework, the key things we're focusing on are these two types of proteins. So one is amyloid that's deposited in the brain outside the nerve cells, and the other one is tau, which is deposited inside the nerve cells. So plaques and tangles, amyloid and tau are these two proteins that are really important for our therapeutics, trying to find strategies to try to prevent Alzheimer's disease. So again, focusing on what we see in the person and what's going on in the brain. Previously, we couldn't tell what was going on in the brain until someone passed away. So many of you are aware that you really couldn't diagnose Alzheimer's until there was an autopsy specimen. But again, what we really want to do is to identify these brain changes early. So again, this graph just shows, again, our current FDA treatments don't really treat the underlying cause. They don't treat the amyloid or the tau. So if you think about a normal person, normal aging, if somebody's going to develop a dementia due to Alzheimer's, they'll go through a phase where they have some cognitive changes but are functioning fine, then may progress to dementia due to Alzheimer's disease. But the whole time you can see that there's accumulating Alzheimer's brain changes. So what our team is really trying to do is to identify who has these brain changes, not on autopsy, but with early novel strategies, and try to get them before they develop any cognitive changes here. So currently what our therapies do, if I'm in clinic and I prescribe someone with dementia a therapy, this is what they can expect. It'll slow their decline, but it's not going to get them back up to where they were before, to the person that they thought who they were previously. But again, it does work to slow the decline. Well, why are these therapies not working well? There are two types of therapies in general. So this first one, group 1, has medications like donepezil, ribostigmine, galantamine. You may hear them by their trade names. And there's another group called memantine. If you look here in this graph, if you remember this picture, you remember that I mentioned that these amyloid plaques and tangles are two of the chief causes of this disease. But if you look, what these medicines do is they help these nerve cells connect to each other and communicate better, but they're not doing anything to the amyloid plaques or the tau. And that's where we really think our research needs to target to be able to get rid of the tau and the amyloid so we can have better therapies, hopefully better symptoms that we're seeing in the person. What's frustrating is that there have been no new medications for Alzheimer's dementia for 16 years. The good news is last week you may have heard in the news that there is a new medication that Biogen is presenting to the FDA, possibly for approval to treat. This is the first medicine that actually addresses these amyloid plaques. So we're really at an important point in Alzheimer's research where we really need to identify, does targeting amyloid and clearing that out from the brain help protect a person's brain function and status? So again, what our team is doing is really trying to focus on this point in time. Can we identify people here who have normal cognitive function, but yet have some of these brain changes accumulating, and try to get them on a trajectory that looks different than if they were to progress with dementia? So this takes novel, high-tech diagnostic tools and also careful assessments of the individual, what's happening to them as a person, so we can piece those things together and develop better therapies. So our context to work, our Alzheimer's program is based here at UW-Madison. So again, as you know, we're 6th in the nation for research expenditures. We have 13 schools and colleges, and our program really draws on the interdisciplinary nature of these programs. I know Provost Schultz will say Wisconsin has low walls, and we know each other and we talk to each other, which is what makes for rich research experiences. So if you note here, again, the research expenditures are increasing to over $1.1 billion. And at 50%, over 50% of our federal funding comes from Health and Human Services, so about 96% of that is from the NIH, National Institutes of Health, and a lot also from the National Science Foundation. So a lot of our funding goes to health-related conditions here at UW-Madison. Within UW-Madison, we have the UW School of Medicine and Public Health. What's unique about our school is the first one that combined a medical school with a school of public health. What that means, and we're seeing it tangibly on a daily basis, is that the research we're doing here at UW is getting out to communities faster. So an example of that, we have a conference once a year where we bring together clinicians from all over the state. They get the cutting edge training of how to provide good dementia care, the latest research, and they're going up into rural areas, to Spooner, Wisconsin, to all kinds of counties throughout the state to bring these ideas back to their communities. Again, we have a large faculty here and a large amount of research funding, over $360 million through our School of Medicine and Public Health faculty. And importantly, the dean has identified Alzheimer's disease with aging and then cancer as the top 2 priority areas for research. So again, a lot of institutional support within UW-Madison, within our School of Medicine and Public Health. And we're really thankful to have a lot of interaction with our trainees. So the School of Medicine and Public Health trains not only medical students, but also other health professionals, a lot of interaction with pre-health professionals, and a lot of other scientific training that we do as well. We have a research education component to our Alzheimer's Center. So a lot of research training and clinical training goes on within our program. So our research program at UW-Madison is comprised of 2 groups. One is the Wisconsin Alzheimer's Disease Research Center. The director is Dr. Sanjay Asthana. And then the Wisconsin Alzheimer's Institute, of which I serve as director, and Dr. Johnson serves as associate director of both of these programs. The Alzheimer's Disease Research Center is one of only 31 NIH, National Institutes of Health, funded centers in the United States. We were just refunded for another 5 years, so we are heading into our 15th year. And then our Alzheimer's Institute is closely tied to public health. We do a lot of work with the Department of Health Services and training initiatives. The Alzheimer's Center focuses more on basic and clinical research, and this is where our clinical trials program is housed, which I lead to help develop clinical therapies to address Alzheimer's disease. And then our Alzheimer's Institute emphasizes research, clinical education, and also public health training. You can see the number of employees and staff here. And also we get funding from National Institutes of Health, from the School of Medicine, Public Health, philanthropy, and state funds as well as education and WAI. So again, both of these programs house collaborative cohorts of participants. So the Wisconsin idea is alive in that we have over 2,500 participants who partner with us to help us learn more about what contributes to Alzheimer's, what protects people's brains against Alzheimer's. So 1,000 of those participants are within the Alzheimer's Center. Those participants have Alzheimer's dementia, mild cognitive impairment, cognitively unimpaired, and caregivers. So we were able to do research with all of these partners. the Wisconsin Registry for Alzheimer's Prevention. Dr. Sterling Johnson is the principal investigator for that study. It's been going on for over 15 years, and he'll talk to us some more about the importance of that study, again, studying a group of people who are cognitively unimpaired but at risk for progressing to Alzheimer's. These programs are unique in that this group is able to link to the other 30 NIH centers, so they're able to share data nationally. This is also linked to other international studies that are leading the way in trying to identify Alzheimer's early. And then these work collaboratively with each other to test ideas and also combine data so that we can learn things faster. So there's a lot of collaboration across these without being redundant, a lot of sharing with outside investigators, and Dr. Johnson will talk in more in detail about how our program helps other investigators here at UW and beyond. So again, we're focusing a lot on what we see in the person and also blood tests, spinal fluid tests, brain imaging, really high-tech, cutting-edge assessments here, as well as some of the common things to see how does this affect the person. We also, again, while we're working on trying to prevent Alzheimer's disease, we're also trying to improve care for people with Alzheimer's disease. So Wisconsin Alzheimer's Institute is trying to help reduce this or improve this number. Only 50% of people who have a diagnosis of dementia are diagnosed. If they don't have a diagnosis, they're not going to get into clinical trials and not going to be a part of research. So we're trying to improve that. We educate healthcare professional students on dementia, work with our Department of Health Services dementia care specialists and train them. We support 38 clinics throughout the state of Wisconsin in diagnosing and managing patients with dementia. So we help train them, go out to them. They come to us twice a year. We just had our big conference last week. We also partner with diverse communities throughout the state. So we have strong partnerships with Oneida Nation and Hobart. Dr. Carrie Gleason leads those efforts. We have ties to a Spanish-speaking clinic in Milwaukee, United Community Center. We also have ties to federally qualified healthcare systems. We have ties to programs that chiefly serve African Americans in Milwaukee. And also our Alzheimer's Center has overrepresentation. We have over 20% African Americans in our center and a large proportion of Native Americans as well. And our program really closely aligns with our state dementia plan goals. So I'm going to turn it over to Dr. Sterling Johnson, who's going to continue our discussion and talk about our early biomarkers and how that impacts our prevention trials. Dr. Johnson.
Hi, good morning. I'm Sterling. I'm a professor here at UW, and I'm a neuropsychologist. I'm interested in how the brain changes ahead of the symptoms of Alzheimer's disease. As Dr. Carlson mentioned, we typically think of Alzheimer's as the dementia phase, but this disease starts about 20 years or more before that dementia phase begins. And that's some of the discoveries that we've been making here at UW, in large part because of the WRAP study, the Wisconsin Registry for Alzheimer's Prevention. I inherited this study when Dr. Mark Sager retired. He was a visionary geriatrician here, and he built the WAI, and Dr. Carlson, whose incredible leadership has really taken WAI to another place, but both of us inherited our programs from Mark Sager, so I wanted to acknowledge his founding leadership in this. The WRAP study began in 2001, and you can see our participants are now all over the country. There's some numbers on our demographic characteristics. The mean age right now is about 67. Our people enrolled when they were about 54 years age on average. Most are female. Most have a parent who was diagnosed clinically with Alzheimer's disease. And most have been in the study about 11 years. And typical of Wisconsin, about 40% of our cohort qualify as being obese, 40% have high blood pressure, 10% diabetic, 50% have high cholesterol. These are typical numbers for Wisconsin. And what is different about this study is that 41% have this gene for Alzheimer's disease. It's just a risk factor gene called APOE. And people with this gene have somewhere between 2 and 5 times higher likelihood of getting dementia due to Alzheimer's disease. Just a little more particulars about the study. Each of these dots here on the map represents where one of our participants live. And you can see that while most of them are concentrated here in the state, as they retire and their life happens, they have spread out all over the country. We do have a paper reviewing our progress, and this is publicly available online. We have been using some really interesting and technologically advanced capabilities that are available at places like this because of infrastructure that we have here in our Department of Med Physics and Radiology and the Weissman Center at UW-Madison. We can get scans like this, and these are game-changing kinds of scans. They show us who has amyloid plaques and who has these neurofibrillary tangles. And the case on the left has neither of those. The top one shows this person's amyloid scan, the bottom one shows their tau scan. No plaques or tangles. The one on the right is one of our RAP participants, and they do have these plaques and tangles. And the question is, will this person progress to impairment, mild cognitive impairment or dementia? How long will that take? Can we predict that? Can we inform them of what their years might look like? Those are the kind of questions that our study is trying to answer. What we do know with a paper that is going to be published in the journal Brain in a couple of months, people with plaques and tangles in their brain do decline faster, and that's shown here on this slide where you see these slopes. The red slope are people who have plaques and tangles. They're not demented, they don't have cognitive impairment, they're mostly normal, but they have been declining over time as we've been studying them longitudinally. The people with just plaques or the people that don't have either of those are declining just like normal. So this is really, these technologies are super informative, and they're helping us understand the preclinical course of this disease. This is the RAP program and the ADRC biomarker program, which embodies what RAP is doing and what some of our other studies are doing. We've just grown rapidly, and this is an indication of the number of studies that are linked to the RAP study and to our Alzheimer's Center. We have 40-plus studies. Our funding is just growing rapidly across all of our investigators, and this, of course, creates good challenges in terms of space and logistics and administration, but it's a phenomenal time to be in this field and to see the discoveries that we're able to make because of the place where we're at, where we're thriving. Some of the questions we're addressing: how early does Alzheimer's begin? Like I mentioned, it looks like it's about 20 years. And in some cases, it could be as much as 30 years before those symptoms show up. In some cases, it'll be sooner, depending on what else is going on with that individual. We do want to be able to get to the point where we can predict with certainty who will get symptoms and approximately when they might get those symptoms, depending on their biomarker profile. You've probably seen in the news, probably every other day, you see something in the news about a certain diet or a certain amount of sleep impacting Alzheimer's disease. These are things that we're investigating as well. All of our participants do questionnaires. Many of them come in for direct studies of their fitness level and exercise habits and those kinds of things. We have studies looking at diet, sleep, exercise, mood, social support, cognitive activities. We're seeing, I think, that all of these things improve brain health. They don't necessarily impact the biomarkers themselves, these plaques and tangles, but they certainly do give the brain a buffer, a degree of overall health, increase in the number of synapses and brain connections that might make a person resilient to Alzheimer's disease. So this is the wonderful thing about our brain, is that it's so resilient and capable of rewiring itself, but it makes it very difficult to study because it's such a slippery self-healing organ as it is. But we are studying this, and this is just really interesting parts of our work. We're looking at artificial intelligence and deep learning to examine the scans and the vast array of genetics that we get on our individuals and other parameters. We're designing the next generation of clinical trials using these kinds of biomarkers as outcomes. We're coordinating and collaborating with our colleagues in radiology and medical physics who are finding new ways of understanding vascular disease, which is the most common comorbidity with Alzheimer's disease and the thing that gets confused most often with Alzheimer's disease. And so we're making amazing strides in all of these areas. So just kind of summing up this part of it, we're examining novel brain biological markers in imaging as well as spinal fluid and blood tests. And by the way, blood tests are on the way for Alzheimer's disease. Right now, there's nothing that we would hang our hat on clinically, but it looks like there's some good things on the horizon. Once we understand who has Alzheimer's disease, we're looking at the health and lifestyle characteristics that might provide them some buffer or resilience, including things like their gut microbiome and, again, how much sleep they're getting or their blood pressure control. And then finally, we're evaluating the impact of these things on their overall brain health. We do have a fairly large clinical trials program that Dr. Carlson leads. We have you see one of our volunteers here, Bucky. You see him get him a lumbar puncture here. This is where we pull spinal fluid out of the back, and that's the kind of fluid that it produces. It's a clear fluid that contains these proteins in the brain, and Dr. Carlson leads this program. And plus the fancy imaging and the cognitive testing that we do. Our clinical trial program is nationally recognized. This is one of our participants. She gave her permission to have her identity on the NIH's website for their trial enrollment program. And our trials include many things, including several prevention-related trials and and also trials for people with mild cognitive impairment and even the dementia stage. So we have a number of things going on. It's a comprehensive program. RAP is one part of a fairly large program. We are in a place where we're thriving, and in a place where there's somebody who knows, who's an expert on something that you need as a researcher who can help you get it done. And so it's been a wonderful place to thrive for our program. Our groups are partnering with numerous departments across the campus, from computer science to psychology to statistics and medical physics, and many departments in the med school like neurology and biostats and psychiatry and geriatrics in the Department of Medicine. We are partnering with participants all across the state. Our participants, as you saw, are so committed to this enterprise, and they inspire us to do what we do, and we meet with them fairly regularly to update them on this progress that we're making. We have a commitment to improving the diversity of the participants that we're studying, and making sure that our findings are applicable to diverse communities all across the state. We have outreach and clinical training opportunities, and we are improving dementia awareness and the capacity of our healthcare system to care for persons with dementia and their families. And we think that research here at UW-Madison is helping us diagnose this disease earlier and identifying promising angles for prevention strategies as we go forward and face this disease at this time. As you know, the baby boomers are aging. As Dr. Carlson pointed out, the Alzheimer's disease is on the rise, and we at UW-Madison are ready to address this. Okay, I think that's it. We'll stop there, and maybe Dr. Carlson, if you want to come up and we can take any questions.
Either that or Dr. Jones.
Or I can go down there. Let me do that.
Meet us at the table. Thank you again, an enormous amount to digest here, but very, very informative. Questions? Regent Whitburn.
I think one of the most stimulating and worthwhile experiences that we have is to come here and from time to time, in particular, hear from our genuine stars and the work that you're doing. Dr. Carlson, you were educated elsewhere. You said you came here in '95?
Yes.
And you're doing this incredibly important work, which we're grateful for. You stressed at the top of your presentation that we rank 6th now in research. Help those of us in this room to understand your sense of how we move from 6 back to 4.
As I can speak from our program's perspective, but again, I think one thing that's helped our program succeed is the collaborative nature of working across programs to be able to develop better research ideas that include fresh ideas from other departments. We as a group will train upcoming medical students, postdoctoral fellows, graduate students. I think that interdisciplinary nature helping to help them to get good ideas and to integrate them into the research so that they can, again, the labs can be more productive in a way that helps them advance in their careers. So I think that collaborative nature, linking our programs to funding opportunities. So again, National Institutes of Health has increased tremendously the amount of funding they're pouring into Alzheimer's disease, recognizing nationally this national crisis that's coming. So again, aligning our work, which it does well, with federal imperatives. And also, a lot of us on our leadership team are a part of national programs to help us understand what the national emphasis is for NIH and other funding agencies so that we can hopefully continue to work across disciplines, bring in the next generation of scientists, and also to align our work with those other national priorities. And if you want to speak to that, Sterling.
I think that's exactly right. We're in a place where we have an exciting number of junior faculty who have bringing their own clever ideas, and our more senior faculty are developing national and international collaboration. So those are the kind of things that I think are going to boost us back into the top 5.
You know, we spent some time talking about public funding and grant funding and NIH and NSF. Can you give us a sense of the interplay that you have with private sector investments, therapy, discovery work, how that interplay takes place? I'm just curious.
So one example is we are a site for this study called the A4 study, which is the largest international prevention study looking at trying to give that anti-amyloid therapy into people who don't have memory symptoms yet, but have some of that amyloid changes in their brain. So one example is that is a joint collaboration between NIH and Lilly. So again, NIH helped develop the science behind it. Lilly helps with the FDA component, the regulatory component, making sure that the right outcome measures are in place to get that medication approved. So a lot of us are trying to learn how to navigate that important segue between the scientific ideas, but also working with industry so that they can help get these medications through in a way that's streamlined. So hopefully we don't have to wait another 16 years for a new therapy. And then Sterling, I know you've worked with industries for early identification too.
Yes, I think Alzheimer's is a good example of how industry and academia are cooperating, collaborating very productively. We have some national studies. One that comes to mind is the Alzheimer's Neuroimaging Initiative, where all the pharma companies come together pre-competitively. They help fund this thing together with NIH. That's an important example, and all the data that we collect goes out to, in a secure way, to the web where the scientists throughout the world can look at it and apply their brilliant ideas to this data. Another example is in our own labs, in our biomarker lab, we've been able to partner with Roche to get an equipment grant for one of their cutting-edge next-generation machines so that we can do the very latest biomarker assays on our participants. And that gives us a competitive edge with our colleagues and also is going to help us just make discoveries that much faster.
Other questions, Regent Beckton?
Just following up on that, Regent Peterson's question, are there any obstacles or any policy issues that you would identify making those linkages between private and academia that we should be aware of and that we could be working on or looking into?
Personally, I think it's maybe just the mindset needs to change a little bit among some researchers. It's who often think of academia and big business as separate entities and they shouldn't cross. So I think as more people get comfortable with those collaborations and more gatekeeper type people get comfortable with that, those will be easier to do.
I think kind of helping accelerate the progress for forming agreements between academia and industry. So trying to accelerate that progress. Sometimes there's a lot of back and forth between the attorneys for both teams just to make sure that there's good agreement on intellectual property issues. So it needs to be done, but sometimes we wish it would go faster.
Let us know, please, because many of us are leaning in on this subject. So anything that you ever identify, please be open with us and communicate.
Thank you.
Yeah.
May I ask a follow-up question to that? There have been a number of folks that have mentioned to me the difficulty that Wisconsin has in hosting clinical studies. Would you shed some light on that?
Yeah, so we just had a meeting yesterday. So the School of Medicine and Public Health has hired a new person, Ms. Betsy Nugent, to help coordinate clinical trials progress across the university. So helping not only with pharmaceutical-sponsored clinical trials, but drawing that in, but also to help people within clinical trial work to be able to accelerate, develop career development plans for research coordinators and research clinical trialists. So there's a big emphasis within the School of Medicine and Public Health to address this. I think we agreed yesterday that a lot of the components are there, very strong components, but trying to be able to make them more cohesive and the system work better together is one a big emphasis. So she just started, I think, about a month ago or so. So before she, make sure she gets her office settled before we go knocking on her door. But she's got a lot of great ideas. So I just met with her yesterday.
Regent Delgado.
Yeah, I have a question. One of the things that perhaps some of you, either one of you can comment on, is the data that we're seeing, are the data that we're seeing valid that there is a greater onset of this type of illness, or do you think that maybe that we're better at identifying it? All of us now seem to have a greater awareness of people that we know, including in my family, that appear to be affected by this. The question is this a valid, what is your sense of it? I have a second question to follow up. There you go.
I think the answer is a little bit of both. We're living longer, and so there's going to be more of this disease because it's an age-related disease that usually expresses in our 70s and 80s. And so as more of us live into those ages, and as we get better at curing other diseases like heart disease and stroke and cancers, this will be the disease that we're going to be faced with. So there is that, and there is also the fact that we are making people more aware of this and helping them realize that there's nothing to be ashamed of, or kind of lowering the idea of stigma, and also increasing the resources and tools in primary care and specialty care so that they can deal with this. And that's really been the focus of the WAI.
The second one is, are there geographic focus of locations, locus of greater incidence of this illness, or this is too early to identify anything like that?
I know there's some conditions like multiple sclerosis that might have some geographic predominance, but again, I think for Alzheimer's disease, so far, most of the work has been in different, people from different backgrounds. So African Americans, people from Hispanic, Latinx background, Native Americans probably have a 1.5 to 2-fold increased risk of developing dementia. We're also looking at social determinants of health. So Dr. Amy Kind is looking at, are there different factors related to whether someone has a disadvantaged neighborhood, access to good health care, other resources, to see if that impacts a person's risk for dementia. So it may not necessarily be a big geographic area, but maybe how advantaged you were within your community and those stressors and how that plays into Alzheimer's risk.
Thank you. Any other questions from the Regents? We're a little behind schedule, but I think we've seen from our last 3 presentations how impactful these efforts are, and so for that, we're certainly grateful to both of you doctors for being here today. Let's give them a round of applause.
Thank
you. As President Cross mentioned in his introduction, we're going to spend some time discussing the scope and significant impact of research that's being done in the UW system. We've asked 3 of our chancellors to join us at the table. So Chancellors Blank and Mone and Van Galen, we welcome you this morning. I think for Regents' benefit, the intent here is to really jump right in with Q&A, and my sense is we're all a bit curious as to how we can continue to accelerate the efforts that we have on our campuses. So with that, I'll turn it over to President Cross, who I think will begin with our first question.
What we're attempting to do is give you some insight into some of the research that's going on. This is just a tip of the iceberg. So what you saw earlier is an effort to identify how best to improve drugs that deal with pain, opioid, cancer issues. And then you saw students working on a problem to deal with bees. But people don't understand if we don't deal with the colony collapse issue, or the other issues that threaten bees, our food supply is in threat. So it's incredibly important to us. And then you're listening to our folks talk about Alzheimer's, and both Alzheimer's and cancer as the 2 priorities for this research. And to me, those are self-evident things that the university is doing to improve the human condition, just right out in front of us. And that's important. And I want to pull from that question that Regent Whitburn asked, and I want to pose it to these folks to start the discussion. One of the things that Regent Whitburn asked is, what is it that caused Madison to drop from 4 to 6? And if you notice, that number's going back up in that graph, so you're seeing it go back up. But I want to speculate and ask this question. It typically is the hiring of faculty who do the research that makes a difference. And in this particular case, I know Regent Blank, or President Chancellor Blank has hired clustered faculty in significant number. And you heard the faculty describe their interest in coming here because of their opportunity to collaborate more easily than other campuses. The question is it a fair assumption that the hiring of faculty, really competent faculty, and cluster groups has a direct impact on research dollars and efforts?
Let me start, and I'll let others add in. I actually think the most important thing for research dollars is having, and both hiring and retaining absolutely top faculty, and then creating the atmosphere in which they can interact with each other. So increasingly, science is not about a single faculty member in their lab or in their office doing focused research on a very narrow problem. The sort of big science funding that is out there from the federal government increasingly is going towards big science problems which require multiple disciplinary teams of people with different lenses, different skills coming together to look at things like brain science or about artificial intelligence. And that requires not just having good faculty, but making sure they talk to each other, right? And get together in those teams and can then put in the proposals that are going to win the dollars. We at Madison have a long history of collaborating. partly because of the closeness of all of our different units across campus to each other. And that has been a real advantage to us and one reason why we have been as high in the research rankings as we have.
So I'll speak to that from a comprehensive university, primarily undergraduate institution. If you think about our faculty, they come to those institutions because they're passionate about teaching, but also they want to be teacher scholars. And more they value the ability to interact with students, to serve as mentors in a variety of disciplines. So our ability to attract faculty at the comprehensive universities more and more is connected to our ability to support them in that effort to work with undergraduate students in research across disciplines, right? It's not just the sciences, it's art, it's history, it's archaeology. We saw some of that this morning. And so the key is to build an opportunity, a culture in which undergraduate research is valued at the institution and supported. Because in the end, the faculty are the key drivers in working with these undergraduate students as mentors, as role models, as examples of lifelong learning.
And I'd agree with both of my colleagues, and I think all of the chancellors would reinforce this idea that, first of all, President Cross, to your point about the clusters, I wish I had the resources to hire clusters. What I'm hiring right now, when we do have faculty opportunities, is what we call connectors, individuals who will bridge the gaps, bringing these different pieces together, because that is the funding agency model. That is very much how scientific advances are made today, is through the contributions from a lot of different areas. I would point out that one of the things that happens when I go to national conferences often is that I meet with other presidents and chancellors, and they're very apologetic because they have had the opportunity to themselves recruit from our faculty. That we have some of the most attractive faculty in the nation because of their advances in many ways. And so it's that kind of competitive landscape. It's truly a war for talent. And that's something I think that's critically important to be aware of. To address Regent Whitburn, your question in terms of how do we move up at whether it's the flagship or at our other Research One or across comprehensive universities, I think obviously resources are a critical issue in terms of what we can put in future UW system-based budgets. But I think we can also do some other things. I think we're particularly effective at partnerships. You heard some of the faculty stars that we had here, as well as some of the students talk about that and how collaborative we are, both within and across different areas. I think how we tell our story is critically important. If you go to other states, oftentimes you see amazing campaigns. Colorado is one example. You cannot take any transit, you cannot go anywhere in Colorado without hearing about what the University of Colorado system is doing. I think that's really important. The other aspect is what you heard today are some stories based on individuals who are really good at telling stories. We have to do even more of that. We're not all uniformly good at that, in terms of really how we convey that. Alan Alda has started and really been instrumental at SUNY Stony Brook for talking about how scientists in particular can tell their stories better. And it's amazing when you see the before and after, when individuals who are the most advanced knowledge experts, but then when they go through basic training in terms of thinking about empathy, how others interpret and hear your story, and then just the remarkable turnaround. So I think things like that can be very, very beneficial as we do more around like the All in Wisconsin and other things to raise the consciousness of the true impact of the state, or of UW on the state.
Very well said. Couldn't agree more. Regent Atwell.
Thank you. That's fascinating presentations, and we've had the opportunity to kind of celebrate some of the successes. I'd like to follow up with a brief social science experiment live here, using a highly refined technique known as I'm thinking of a number. And so I'd like to invite each of you to participate in this exercise. Are you willing to do that?
10.
Yeah. So we've heard about some of the successes. On a scale of 1 to 10, I'd like to ask you to independently, after brief reflection, write down a number of how effectively are we actually fostering, supporting the kind of research, what on a scale of 1 to 10 of realizing the potential that we have. where with 10 being, you know, we're right there, and with 0 being nowhere.
For our institution.
What's that?
For our institution.
Yes. So if you don't mind participating, take 10 seconds, write down your number. Don't look at each other's numbers, and then and then if you each debrief.
You want a decimal point or just?
I would invite you to be not overly complex.
Chancellor Mone needs a pen.
I need a pen. I'm not really looking at
Right
your,
in
your
blood.
sheet there. Just thank you.
Okay, are we ready? Could you guys just please debrief? Tell us your number and why.
Okay, so the question is clearly around how far along are we in terms of realizing our potential to cultivate and create the types of research opportunities. I'd give it a 5. I'd put us right in the middle of the pack. I think that we have remarkable faculty, staff, and students. We have just made great strides, but I think in terms of what we could do more and really have momentum and really move the needle and have the UW system seen as an even greater powerhouse, that I'd put us middle of the pack.
Thank you.
So I went with a 7, and part of that is based on what I've seen around the country in terms of commitment to undergraduate research in particular. Wisconsin is strong, perhaps one of the leaders. So as I look at our comprehensive campuses, I think every one of them has made a commitment to engage students and faculty in undergraduate research. I think WISES and their involvement has helped evolve the culture at the comprehensive campuses more towards innovation. They've supported undergraduate research in great ways, and I think our faculty now are entering these institutions with an interest and commitment to engage students in undergraduate research across the disciplines. So I feel we're good, but there's room to grow.
Thank you.
So I did my ranking just for UW-Madison because I can't judge the rest of the system.
Well, you could, but.
Not well. I mean, I put down 8 for UW-Madison. We're one of the top 10 research universities in the country. We have an absolutely superb set of faculty in a whole range of areas, but we've lost good faculty, and particularly around that whole time of budget cuts and the tenure debate. There are things we're not doing as well as we should. You've mentioned one of them, which is clinical trials, and we're putting in place some things to improve that. I would say we don't do industry-funded research as well as some other places, and we're putting some things in place there. There's certain areas where we have gaps that are really important areas of science. So you should want your flagship campus in this state to be at a 10 in this area. And 8 is pretty good, but it's not where we should be.
Thank you.
Regent Mueller.
Thank you. Let me just switch gears a bit. I'm looking at this slide that says the future of research. And it seems to me, from what I've heard today, the future should involve a lot of discussion on ethics, medical ethics, and ethical behavior in the research. And I wonder what advice you would give to us as Regents as we try to oversee that. One of the presenters today used the word stigma, and I was struck by that because there would definitely be a stigma associated with all of us taking a test for Alzheimer's, and how are we going to deal with that? Because from what we've heard today, it seems to me we'll be able to identify risk before we ever identify a cure for this or any other disease. So again, just my basic question is, how should we oversee that ethical side of research? We're so good at tracking the money, tracking where we stand in the country. I love serving on the Business and Finance Committee because we hear all the time about new research contracts coming in. But there is that whole other side. I'd be interested in your thoughts on that.
So, this is something that I think anyone in the research field, whether it's medical or even in large numbers of other areas as well, there are always ethical questions out there. It is something that the federal government spends quite a bit of time thinking about, and to the extent that a good amount of our research is funded by the federal government, the sort of things and the controls they have in place on medical research, on animal-based research, are really quite extensive. And, I've often say that we're one of the most highly regulated industries in the country, certainly our research enterprise is. And, there are large groups in Washington who spend time thinking about this and what are the constraints that you should put upon universities. And I think my first reaction is, I'm not sure that is the first job of the Board of Regents. It's not a question, it's a question you should be asking. You should be asking us, how are we dealing with this? What are some of those controls? But, we are already quite highly regulated in this area, okay? Now, having said that, it's a conversation which you really want to make sure is happening on campus, particularly among the people you're training. One of the things I'm very proud of on campus is that we have a number of people who work in the ethics of science, and one of them, Alta Charo, is really one of the most nationally well-known people in this whole area, and is very involved in discussions with our scientists on a whole host of these issues. We have a variety of seminars available, particularly for our PhD students who are going to go out into the research world, that ask some of these questions and get them thinking about them. And if we need to be training on these issues, not just talking to our current researchers, but making sure the researchers we're preparing for the next generation know that this is central. It's not just the techniques of research, but it's what is the meaning of this and what implications does it have.
I would largely echo Chancellor Blank. It is a very regulated activity. However, when I talk to students on campus about their undergraduate research projects, research in the Rotunda, they're very well aware of, I think, the ethical aspects of what they're working on. For our campus, that includes animal welfare, and so they've thought deeply about the implications of research on animals or humans, but it is highly regulated, and I think our faculty largely have a very good handle on this.
I think I'd echo those comments as well, but I'd add something. As much as there's external bodies that are involved with regulatory activities and oversight and frequently monitor and hold us accountable, we also have our own institutional review boards and our own training with respect to how we have expectations for our students, those that we train, and what faculty have to uphold. I think it could be beneficial for future conversation for the Regents to hear and understand exactly how that happens on campuses, and so that you have a good sense of the safeguards that we do have in place around the ethical treatment of whether it's human, animals, or other areas. There are risks today, and we see this on the international front. We have no shortage of individuals from security agencies, FBI, and others that are keeping us well aware of a lot of the issues that are occurring with respect to data breaches and other things that are happening. And we heard in the news today about individuals that are at Twitter and the risks and exposure that we have with data. And so that's the evolving world around which ethics play an even more important role. So I think that's something that we'll have to be even more aware of.
Can I say one thing? There's often a discussion about tenure and, what are you getting rid of people with tenure and, one of the one way that I can promise you that you get rid of a tenured faculty fast is when they're found to be falsifying evidence. And that ethical stance is absolutely deeply embedded in the research world inside almost any field that I know of at the university. That, if you falsify your research, you are gone, and you will never get another grant. You will have real difficulty getting hired elsewhere. Your reputation is ruined.
That's a good check and balance. Regent Hall.
As you're thinking about the future, what kind of thinking have you each given to increasing, faculty of color, students of color in research?
One of the examples that I'd give that we have supported at the UW system level, we've also had National Science Foundation funding, is around our WisCamp STEM program. And we profiled that at the June Board of Regents meeting. And that type of program has been so important for us to advance students of color in scientific fields. So that's one piece. I think what's really rewarding and gratifying about our recent campaign is that with the number of students that we have out from underrepresented populations, we've had a lot of scholarships specifically aimed at that. So, for example, this week we had almost 20 students that were recognized by the Bader Philanthropy Group for their work in scientific fields, all from Milwaukee, all students of color in different areas. That's not the scale we'd like to be at. That's not hundreds or thousands, but it's those types of programs that we need to really grow and reinforce.
What about faculty?
Faculty continues to be a challenge on a number of fronts because of some of the same dynamics we talked about earlier. The competitiveness of faculty of color, they can go an awful lot of places where there's just huge recruitment opportunities. So that's something where we need to grow our own. We need to do more in the pipeline. We need to do more at the undergraduate level to encourage and reinforce that.
Regent Jones. Oh, sorry.
Yeah,
Dean.
2 points. First, it's an excellent question that's receiving attention at the national level. If you look at the Council of Undergraduate Research, or CUR, they're really the umbrella organization nationally for undergraduate research. They're focusing on this. Locally at UW-River Falls, 2 years ago, we started a program called the Aspire program. This brings in up to 50 students, largely underrepresented minority students. 96% of those students are from that group, and low income and first generation students. There's a mentorship component, but also there's a part of this that provides them with a stipend for a high impact practice. It could be undergraduate research, study abroad, or internship opportunities as they progress through their time at River Falls. So we're trying to do more to make that connection of how do we engage underrepresented minority students in some of these high-impact practices where historically, nationally, they have had less participation. So I think that's an example of something we're working on at River Falls.
One of the programs that we started this last year that I'm really excited about is called our Targets of Opportunity program, and it's aimed specifically at faculty hiring for departments of underrepresented groups, and it puts money into departments to make a proposal to hire someone who would not be part of their normally approved hiring, but who is a target of opportunity by bringing diversity into the department. And that could be gender diversity, that could be racial or ethnic diversity, that could be intellectual diversity of some sort. In our first year, I think we had something like 47 proposals from departments in every single school and college. We approved around 35 of those, and I believe we're going to end up with about 20 direct hires as a result of that, which is a very good ratio. If you start making one offer and have to make that come through. And we hope to run this program for a number of years too. And over time, that is really going to make some real difference. And we're really trying particularly to focus on some departments that have very, very little diversity of any of those things. And so I've been real pleased with the response on campus. But at the end of the day, the pipeline in many fields is just really too low. And we've got to be working on pipeline programs. Madison gives more PhDs than any other school in the country. And that puts a particular responsibility on us around pipeline programs. We have funding from the National Science Foundation, from a variety of other places to run graduate training programs for students in different areas. I'm particularly proud that a number of our departments run summer programs in their specific field that bring students of color to campus as undergraduates often, to give them extra training and excitement about this field and to interest them in staying in this field for long-term careers, whether it's graduate study or other things. And it's those sorts of programs that are just absolutely necessary still. We've got, the numbers are way too small, and it's not just students of color, it's women in some fields, it's across the board.
If I can give one more example, we rolled out, and Dr. Joan Prince, she's helping me lead a diversity, equity, and inclusion framework. The first portion of that we've rolled out this fall, and we don't have, you ask about from a faculty perspective, we're down from 830 some faculty in 2014 to today 685 faculty. So it's incredibly hard to expand diversity when we're actually contracting, but that puts the focus, I think, as Chancellor Blank has talked about, particularly on retention. And so that's where we're focusing an awful lot of our efforts to really engage and examine what are the issues and really involve individuals in terms of creating a culture and climate where you have the types of outcomes and the impact that we want to continue to have.
Thank you.
Regent Jones.
Just a quick question for Chancellor Mone. Do you have, or do you plan to have, a WARF type of organization to support research at UWM? Because you create this victorious circle when you do that. You commercialize
Yeah.
things, which can fund
Yeah.
more research. So I'm just curious.
Yeah, let me answer that quickly and then also expand on it a little bit. It's really exciting what's going on. We created our own research foundation. We had been part of the original WISE's conception, but about 14 years ago, we actually created the UWM Research Foundation. So that's our WARF. So we have that covered around patenting, licensing, technology transfer, and things like that. All the IP issues, everything is contained there. So we feel really comfortable about that. What I'm especially excited about, and what you'll hear more about in the future, is what we're exploring with WISE's, WARF, and our UWM Research Foundation, where we're asking questions of key legislators and others to identify some of the key challenges and problems in the state, and then for us to think as a system about how do we apply technology advances, how do we apply together, pulling from all parts of the system with really some great things that you heard from Arjun earlier, and what Eric Iverson and what others are working on collectively. We had a pivotal meeting several months ago, and we're building on that, and you'll hear more about that. But it really helps us operate as a system because, as you heard in some of the presentations, no one campus has all the different areas of expertise. You heard about what Madison is doing in terms of collaborating with outsiders, what we're doing. So this is really a neat way to think about how we harness the power of those research foundations working together. It's pretty exciting.
Thank you.
Other questions from Regents? Regent Woodmansee.
Thank you so much for speaking today. My question is surrounding undergraduate research. I'm just curious your thoughts as to what you believe is the largest kind of stopper from students getting involved in undergraduate research, and then how are you at your institutions combating that obstacle that they may face?
In terms of the obstacles, I think I'll speak to faculty and students. For faculty, it's time. You know, at these comprehensive universities, the faculty have significant teaching responsibilities in the classroom preparation, grading, all of that. And so how do we help the faculty find the time through perhaps a course release or perhaps through the summer? For students, I think the obstacles also are time, right? There are full course loads, but there are some creative ways to overcome that. For example, undergraduate research can be embedded in the classroom. We have a program sponsored by the Howard Hughes Institute where in a freshman biology class, instead of the traditional biology experiments, students are doing undergraduate research and discovering new phages. And so that's one kind of creative solution. I think the other is funding. Many of our students hold one or two different jobs. So how can the institution provide stipends either during the year or during the summer? And we've done quite a bit of that actually with some funding from students actually who value this activity very much. So I suppose it's time and money, but that's also embedded in the culture of the institution, and is it prioritized in the university's strategic plan?
Yeah, I mean, I think things at Madison are different for a variety of reasons. One, many of our faculty have research grants, and they want, using undergraduates in those grants is often a very effective way to both get work done and to get involved with students who the faculty enjoy. When we ask our graduating seniors, which of the following things have you done, about half of them say they've been involved in research with faculty, which is a very high number. And I think an indication of the fact that our faculty really look for this and welcome it. If you ask me what keeps a higher number, I think it's that students don't think about this as a possibility. Well, I'm not going to be a researcher, so why would I go do that? And I think there's a lot you learn by participating in research, even if you yourself will never walk into a laboratory again. The biggest issue for us is to communicate to students when they come on campus and they're sophomores, they're juniors, they become majors. The fact that there are a good number of research projects out there that want undergraduates, and they should think about this, and they are paid. It's a good way to spend a summer and actually learn a whole bunch about an area of the world that you might not have known as much about before.
So my themes would be similar, but I'll add a few twists. One is that, we received last year, we're one of 2 universities to be nationally recognized by the Council for Undergraduate Research. And it was really, really prestigious. Several of our students went to Washington, D.C. and helped receive the honor. We've grown dramatically the number of students involved in research, but still a majority of students don't participate as actively as we'd like. What you heard from Doug Stafford today, who runs our Milwaukee Institute for Drug Discovery, is all our chemistry students are required to do research. We have a number of students in natural sciences especially. We've increased dramatically the number of number of hours in experiential activities, and a lot of that is around research. So we've more than tripled that in the last 5 years in terms of where we were and where we are today. So whether it's in the arts or whether it's in business or in some of the more scientific fields, really asking students to do more through requirements and creating a culture around that. So for our 60th anniversary, where we had been at 37,000, I said, we're going to be at 60,000. Well, we blew through that, and we're now approaching 90,000 service hours. A lot of that is embedded around research. So it's creating that culture and doing more. But at UWM, because so many of our students work, that is probably the biggest impediment is to how do they squeeze that in when they're working so much and already taking a lot of time to support themselves.
Well, just a comment. We spend a lot of time talking about what the UW system's doing to prepare our students for career readiness and the workforce pipeline, but one-day meetings where we can really focus on the impacts that our campuses are having beyond just that scope, I think, are pivotal. And we just scratched the surface here today, but I hope as it relates to Regent Atwell's, a non-scientific survey, we've done at least an 8 to give some insights and direction to all the things that we work on our campuses every day. We're doing cutting-edge research. We're doing things that are leading to discovery that will likely change lives over time. And I find that we don't spend enough time talking about that as a board and certainly as a system. And I hope we do. I hope we do more of that. There's always a focus on internships and co-ops, but as Chancellor Blank said, there's a lot of utility in spending a summer doing something that you don't have familiarity with, so you can not only learn new skills and talents, but also appreciate what's taking place within the institution that you may not have previously had exposure to. This has been incredibly insightful from my perspective, I hope, to the whole board. And with that, Mark.
If I could just offer one more thing. I think we'd be remiss to not acknowledge one thing that to me is pivotally important. The UW system is seen as the great provider of talent. We're doing much better at retaining talent and keeping it in the state. But I think to harness the economic engine of research is an opportunity that we all just have to reinforce more. There's no strong economy that doesn't have research university at the heart of it. You think about what Stanford has done for Silicon Valley, what happens in Boston with all the campuses around Route 128, Austin, Texas, and that's what you see in Madison. I think you see that increasingly, but every single one of the campuses is that hub in our respective areas in the region of the state. And it's a lot of times those talent and research partnerships that are really important.
And I will say, I think that is something that is still deeply underappreciated in the state. And our advocacy for the importance of research throughout the whole system and through the business community just remains incredibly important. We're not where we need to be, and the public recognition of that.
And this was to give a glimpse to that, right? And we need to do more of it. And I think what's at the genesis of all of this is our faculty and our staff that are having those research, breakthroughs. They don't get enough attention and accolades for the kind of impact that they're having on our campuses, on our communities, on our economy. And so hopefully we can continue to do, just these things going forward. President Cross, I think you wanted to make a final comment.
Yeah, I just want to thank these chancellors, but if we could have picked any one of these chancellors, could have articulated this as well. Both Chancellor Blank and Chancellor Mooney mentioned something, and I want to bring this up, and I'm going to tell a little story as a part of it. And I'm being cautious about the story because as soon as I start telling it, you'll pick up on something. But it's often difficult to communicate effectively what this does. And Mark talked about Alan Alda's work, and I participated in that when I was at the SUNY system, and it was just comical to watch a scientist try to explain something and then Alda retell it and show them how to tell it in another way. It was comical. And so part of what I'm concerned about is the ability to communicate to the public, and in particular legislators, the value and importance of research and why that's so critical, and why the university is at the center of that. And I tell that, and I say that because I'll tell you a little story. When I was in New York, I got a call from a legislator who said, Ray, what the blankety blank is going on in this research project that you're part of? I wasn't directly, but our folks were. We were partnering with Cornell on a research project dealing with the ability to break down cellulose. And of course, that had to do with cellulosic ethanol, and we were trying to find effective ways to break down cellulose, which is complicated. Anyway, dealing with 5 and 6 carbon sugars is not that's your bailiwick. But nevertheless, I said, I don't know, I'll try to figure this out. Well, it turns out a couple of faculty at Cornell were going to Costa Rica as a part of this research project, and they were studying the mating habits of beetles that lived in the canopy in Costa Rica. And I thought, what the heck does that have to do with breaking down cellulose? And that, of course, is what the legislator wanted to know. So I said, you're going to have to explain this to me. He said, well, look, those particular beetles break down cellulose better than anything we can find. And we're trying to figure out whether we can actually mimic that or synthesize that gut bacteria, or we're going to just have to mate a whole bunch of them and grow it. And I started laughing, and when I called the legislator back, he just broke out in laughter, because part of what we need to understand is the public doesn't understand what some of this research is all about, particularly basic research that ultimately leads to something. And the better job we can do of explaining how important this is and why it's being done is critical. And I hope that, as Chancellor Blank mentioned, helping legislators and the public understand the value of research to this state is critical to our future. And I just want to emphasize that. And thank you for participating. I'm sorry to prolong this, but back then it was a funny story. So,
thank you, Chancellor.
Thank you.
Before we break for lunch, I believe President Cross wants to add emphasis to an event that's expected for later today.
yeah, I want to remind everyone of an awards ceremony that will take place this afternoon right here in Gordon Dining and Event Center. At 3 p.m. in the Symphony Room, the UW system will be recognizing outstanding women of color in education, as well as the Dr. P.B. Poorman Awards for Outstanding Achievement on behalf of LGBTQ+ people. So the men and women we are honoring are each doing very impressive work to improve the educational and personal experience of our students and all of those who are part of our campus communities. It's been one of our top priorities to develop the talent and ideas that raise Wisconsin's quality of life and serve the world, and that means we have to put all students on the path, and I repeat the word all students on the path to success. So I invite you to join us at 3 o'clock.
Thank you, President Cross. At this time, the board is going to recess for lunch with chancellors in the Sonata Room, and then 30 minutes following that, we will reconvene our meeting in the Sonata Room, and the board will move into closed session. With that, we stand in recess. Thank you.